Good evening, everybody, and welcome to Modern Day Debate. Tonight, we're going to be debating the globe. Is it a flat? Is it a sphere? So we're going to hand it over to Allan for his opening statement there. Oh, I think I might have gotten that backwards. But yeah, correct me, Allan. You got the floor.
Nailed it, brother. All right, cool. So we're going to go in with the prerequisites for the globe. So the biggest one being motion. So that's something that I'm going to cover. Let me set up the screen share. There's the button. Screen share.
Yeah, I'm ready when you are.
Yeah, looking for the particular sharing window. Why does it?
Always disappear when you need it to be there, right?
Dude, when I need it, it's like, no, I don't know what to do.
Oh, well.
So let's see, screen one. All right, well, no worries. I'll just share monitor two.
Go for it. This is an opportunity
Should
for
work.
everybody to smack the like button because we're going to have a lot of fun tonight.
All right,
All right.
1 second. So,
You let me know
what do you,
when you're
what
ready.
do you see on your end?
Kinetics and dynamics is what we're seeing on our screen.
All right.
Is that right?
Well, it should be, but I just need to know which window it is.
Kinematics and dynamics. If you push F11, it'll full screen you.
F11. So, do you, Toby, do you see the notes panel, or is this the actual presentation
Actual
window?
presentation.
Got it. Okay, we're good. It's just on the opposite window for some reason. Okay, 1 second.
All right, I
We're
wasn't
good, we're
sure.
good.
Sorry,
Yep, sorry about
for the
that.
delay. No, it's all good.
Yeah, it just looks messed up on my end. Okay. Okay, so kinematics means measurement. Kinematics means measurement. Kinematics means measurement. In kinematics, relative motion is true. Some kinematic variables that you might see are t, x, v, a, etc. So distance, velocity, acceleration, right? Those are all kinematic variables. Now, this is going to be important because we're going to be covering motion in the sky. So when things move in a circle, the kinematic relationship becomes extremely important because you can use these variables to describe the motion. For example, the acceleration of the stars must be equal to their velocity squared over the radius, right? So that's kinematics. Now, dynamics gets into the prediction of future motion based on real forces in that system. So the distinction there is kinematics is motion, irregardless of the cause of motion. It's just measurements of the motion, right? And then dynamics is predictions of future motion based off of real forces. Okay, so in 1810 to 1818, a guy named Arago Francois did some experiments with a telescope to prove if the Earth was in motion or not. So what he did was, assuming a fixed ether and that light propagates through this stationary medium, the Earth would be moving through it, and you would have to adjust the focal length of your telescope to compensate for when viewing stars when you're receding or advancing towards them in 6-month intervals. What Arago found is that he didn't have to make any telescope corrections. So this is a huge failure for the dynamics of heliocentrism, as if the motion that is required existed, it would be manifest in these measurements. So here's a summary of the second experiment that Arago did involving a telescope. So in this one, he half covered the telescope with a prism. What he was looking for there was to see if the aberration angle would change when the starlight was passing through just regular air and when it was passing through the prism. What he found was that the aberration angle is independent. It doesn't matter. It requires no further correction, meaning that the starlight is already coming in at an angle. So to further settle the matter, in 1872, George Airy came in with his telescope and to finally put this matter to rest, right? Who's moving? Is it us or the sky? So the situation here is the telescope requires a slight angle to keep starlight coming in at the center. If you were to fill the telescope with water, that would slow the speed of light down, and you would have to make additional corrections to keep the starlight in the center if the Earth's velocity is what was causing the deflection in the first place, right? So what Airy found was that he didn't have to make any further corrections. So that's a huge problem for heliocentrism. So here's the measurements that he put out. So this is in regards to Kinker-Fuse's hypothesis of an ether. So this is, again, a stationary ether, so that any corrections that are made to the telescope can be attributed to Earth's velocity, right? 1 second. So that's the important part to note here. This is not Airy didn't fail to detect the ether, right? This is a velocity measurement. where the correction angle would be entirely attributed to the velocity to produce it, right? So they had a prediction that they were going to have to correct their telescope by 30 arc seconds when it was filled with water, and they only had to adjust it by 8 arc seconds. So it's another colossal failure for the dynamic predictions of motion for heliocentrism. Now we get into Kepler's laws and Newton's laws, right? So Kepler's laws and Newton's laws, they say are covariant, meaning you can derive one from the other, but it's actually just kind of a trick because the mass in these equations cancels out, and it's all about the constants. So the big G, the big M, and the T for the periodicity of the event will output a cubed proportional radius for the orbit, or for the semi-major axis for the orbit, and it's all cube proportional. It has nothing to do with the mass of any of these planets. So what they do is they'll take a they do everything in reference to the sun. So it'll be like the sun versus Mercury's orbit, or then the sun versus Venus's orbit, the sun versus Earth, et cetera, right? All they're doing is just adjusting the periodicity of the event, and the constants remain the same. And the output gives them proportional orbital diameters, right? All right, so that's covering the sky optics and kinematics and dynamics. So in addition to that, if Earth's orbital velocity truly existed and Newtonian dynamics was correct, you could measure Earth's orbital velocity with interferometry with first order measurements, and no such measurements exist. So 1887, Michelson-Morley attempted to make measurements of Earth's orbital velocity. They got 4 to 6 kilometers a second. Then Michelson, Gale, Pearson, where they were saying they were going to measure the sidereal rotation this time instead of the orbital velocity, because they gave up on that by this time, right? So they got fluctuations matching sidereal time measured in diurnal time. And this was another big failure for relativity, because the whole purpose of this was they were supposed to be calculating it based off of curved space-time, and they had to swap it in for flat space-time because they couldn't get enough inertial mass to curve space-time proportionally, right? So this was a failure for relativity to show that relativistic mass and inertial mass are equivalent, because the way that they had to do the calculations, it was a complete failure for them. Right, and then Michelson-Morley was continued by a guy named Dayton Miller, who found a periodicity in the measurements. And when he did his final work, he started doing his measurements at altitude. So he did his last measurements at 8,200 feet above sea level, and found that the drift extent goes to 6 to 8 kilometers a second. And this was further corroborated in 2002 and 2004 by Yuri Galev, who showed using 2 radio links that there is a vertical velocity gradient that gets stronger as you get closer to the sky. So what he measured, he corroborated Miller's work. And how that works is that basically on the surface of the Earth, the speed goes, is greatly diminished. Then as you increase in altitude, you start getting a faster translational speed measurement, and it increases with the square root of the height above ground level. So we have the linear measurements here, starting from Michelson-Morley, 1887, and more of Miller's work, and then Galev's work. So we have a linear gradient that's going up, and that's my time. I'm going to kick it over to Toby now.
Actually, I had another minute left on here because I started your time when you got the screen ready, but fair ball, over to you, Toby.
Yep.
Oh, you're on mute.
Cool, so let me go ahead and share my screen here.
All right, ready when you are.
That screen.
Actually, we're still screen sharing, so you're really ready to go.
Cool, so you guys see my screen there then?
Yeah, we sure can.
Excellent. So we have 3 globe claims. Essentially, we have the claim of motion, we have the claim of curvature, and we have a claim of geophysics. So before we get into all of it, just so in case you didn't know, if you believe in the globe, you also have absorbed all of these paradoxes: the particle wave duality, the twin paradox, the Ehrenfest paradox, the Einstein-Podolsky-Rosen paradox, Schrodinger's cat, Heisenberg uncertainty, Newman-Seliger gravitational paradox, the information paradox, Newton's shell theorem violation, also a violation of maximum momentum and minimum energy rotation, and also a violation of curved visual space, and many more. So let's start with motion here. So we feel no motion. All flight on Earth utilizes a stationary baseline that includes planes, missiles, helicopters. Here we go. We have a flight simulation showing that they use a stationary Earth. Here we have dynamic positioning equations, and they show a non-rotating Earth. Here we have helicopter equations of motion, and they use a flat, non-rotating Earth. So, a question: if pilots have to treat the Earth as stationary and we can't perceive any motion, is there any way we can measure it? Answer: yes, using the induction rate of light, which Allan just covered, we can measure absolute velocity as understood since at least 1818. In 1865, J.C. Maxwell worked upon Faraday's experiments, and he used known values of the electric constant and the magnetic constant in his electromagnetic wave equations, and he found that light behaves as an electromagnetic wave, which requires a substantive medium, aka the ether. And if you look throughout J.C. Maxwell's works, he repeatedly invokes the ether. It was a very well understood premise of all of science up until this point, and that's why in 1887, when they went to go do the Michelson-Morley experiment, they knew exactly what they were doing. They knew their math. They knew the induction rate of light, and so they used interferometry to measure the motion of the Earth. The independent variable would have been the orthogonal vector direction of the interferometer, and as they turned it, they would have got a difference in the fringe shift, and the result was that the Earth wasn't in motion. There was no orbital motion detected. There was a tiny bit of a fringe, and that tiny bit of fringe can actually be explained quite easily with a stationary Earth and an ether wind. So if we measure something to see if it's moving and we get no measurement, it's not moving, right? Well, no, not really, because Albert Einstein in 1905 on the electrodynamics of moving bodies, he says there's no ether, there's a one-way speed of light, and it's always constant. You're not allowed to invoke absolute space or absolute time. Everything's relative. And he says, he invokes imaginary physical experiments. That's how he derives special relativity. He talks about an unsuccessful attempt to discover any motion of the Earth relatively to the light medium, and then he invokes imaginary physical experience. That's how he derives special relativity. So then you got 0.9c plus 0.9c equals less than c, aka 2 plus 2 does not equal 4, because that's what Einstein told us with his crazy math. And then in 1913, George Seismic came along and he said, hey, look, I'm going to rotate the interferometer. What do you know? As I rotate it, the proportional velocity of that rotation actually gets measured in the fringe shift. So it's actually not, the speed of light's not constant. It's measured proportionally to its velocity. And then in 1920s, Dayton Miller came and did a bunch more measurements. He actually started measuring with the interferometer over periods of time, and he found a preferred direction of the speed of light. The ether flow matches the motion of the sky, and the measurement is greater at altitude, and that's related to the motion of the solar system. But then in 1925, they came along and they tried to measure the exact same thing, even though they already measured it once and they said they got a null result. This time they measured it again. They said, oh, that's the rotation of the Earth. So then in 2001, Yuri Galev came along, and now all this time they've never once acknowledged what Dayton Miller said, the fact that at higher altitudes you actually get a greater ether wind. But Galev came along, analyzed his work, found the same thing. Then Galev also did his own experimentation, which corroborated the exact same thing, which Allan already covered. And then in 2004, Ruyong Wang came along. Remember how they said you can only measure that velocity in a rotational vector? Well, guess what? Ruyong Wang explicitly showed that it's actually you can be shown with a linear vector. So if you can measure rotational motion of a linear vector, that means in 1887 they would have measured the motion of the Earth, but they didn't. So and he says here, this would suggest a nanoscale sensitivity. He patented a speedometer based off this exact thing, and he worked with the Naval Research Laboratory to do these experiments. They gave him money, they loaned him his fiber optic gyros that he used to do the experiments. So make of that what you will. But so let's move on now to the pendulum. In 1954, Maurice Elias observed anomalous behavior of his pendulum, and the effect was named the Elias effect. He observed it again in 1956, 1959. He wrote the anisotropy of space, necessary revision of certain postulates in 1997. And then this is showing the eclipse of 1959. You can see in the middle here where you can actually see the full totality of the eclipse, and you see that there's an anomalous behavior of the pendulum. And then he says this is totally inexplicable in the context of the current theory. And here it is again, 1955, another Elias effect. And it's so interestingly, not only did he measure the fact that the totally anomalous behavior during eclipses, but also the pendulum precession rate is relative to the sidereal motion of the sun and moon, aka their annual sky movement. So as the sun and the moon are moving back and forth on their analemma, that's actually affecting the way that the periodicity of not only interferometry as Dayton Miller showed, but also the precession of the pendulum. So that's completely inexplicable within the framework of currently accepted theories. This is translated by an AI from French. That's why it looks kind of weird. But here we have, it is therefore appropriate to consider that the current laws of gravitation are in no way perfectly verified, definitive, and immutable laws, on which basis the assertion that my experimental results are contrary to all the experience acquired in the field of astronomy. These laws, like all experimental laws, are only verified within a certain approximation. Here's showing what this would look like, right? So we have the sun going in the circle here. The moon would also be going in like a similar path. And this is what causes the motion and the shape of cyclones and and hurricanes. It's also what potentially would be causing the precession of the pendulum. And in 1970, Saxel and Allan in Harvard, they measured the exact same thing. Here showing, this is a normal day. Here's a day with the Elias effect or with the solar eclipse. Wow. And they say results of this order of magnitude have been consistently observed at Harvard for a period of 17 years. And then here in 2006, another confirmation of it in Bucharest. Here 2010, they say they found no evidence of the Elias effect. Well, what do you know? They have an electromagnetic break, which keeps the electric trajectory in acceptable values. But, so they say the maximum deflection of the precession of the Foucault pendulum found in these measurements is very far from those obtained by Maurice Elias. But guess what? They never measure the break. So they're breaking out the Elias effect, and then they're not talking about it in the paper, and then they're making a conclusion. Cool. It's utterly meaningless. And then here's another paper where they just try to explain it. They're trying to explain the Elias effect, but they come up with this crazy theory of dark flow acceleration. There's like this, they've got dark matter, dark energy. Now you got dark flow too, because you got to explain the precession of the pendulum. But so why are flat earthers so obsessed with relativity? Why are flat earthers so obsessed with the pendulum? Well, it's because all these things are intertwined with each other. And when you really, really, really start digging at all this stuff, you find that it's all wrapped around one line. You pull at that. And so that's why the ether wind's really important to us, because if you look at this graph here, you see the ether wind's in the middle and gravity's in the middle. So let's get into curvature. So 2018, the FE coordinated laser test, they were taken in Hungary and in the Netherlands. There's the receiver where they were actually receiving the laser. Here showing the first laser test. This one, geoid undulation is the term used to describe the distance of the geoid or above or below the mathematical reference ellipsoid. Geoid undulation was at the same level in both positions. And the pointer was held 4.92 feet above the lake's surface. And it went across the lake 7.46 miles, and they were able to see it. And this is showing it would have had a hidden area of 14.96 feet, but they were able to see it. And here's showing this from the side view of measurement 1, showing the horizontal laser. And then we have measurement 7 from the same series of measurements. What's that?
1 minute left.
Okay, gotcha. You get the point. They tried to measure it, they couldn't see it. But we don't see boats go over the horizon. Where does the sun go at night? Well, it turns out we have optics, and we have curved visual space, and we perceive from a single point in 3D space. Angular resolution imposes a nonlinear drop-off in our ability to resolve items as they move away from us. Your ability to ascertain objects dissipates into an unresolvable angle in a nonlinear fashion. And 6th grade art class actually taught us this. If you really think back to it, train tracks do not actually converge. This is a result of perceiving from a single point in 3D space. And so here's a paper about it. And we say at the bottom, we will show binocular visual space may indeed be explained by a hyperbolic model. Here's showing kind of how that would look. Here's again showing how that would kind of look. And so, as you perceive outwards from here, as you can see, you are taking in more area. So as there's more area to take in, your resolution necessarily has to shrink because there's more coming in. And so here's a direct measurement of curved visual space. The curvature changes from elliptic in near space to hyperbolic in far space. At very large distance, the plane become parabolic. Here's an illustration showing that.
That's time.
What's that?
That's time.
Dang, okay. I didn't get to get into geophysics. I wanted to talk about Pangea. I wanted to talk about magnetogeology. I wanted to talk about the geodynamo model and the fact that the rotational axis doesn't even align with the rotational axis of the convection currents. I wanted to talk about P and S wave shadow zones and how the S waves work on a flat Earth. But yeah, there's a lot to go through there.
All right. Yeah, it seemed like you had quite a lot of in the presentation there. So we'll ask you to stop the screen share there. Don't mind. We can always do more later. So what we'll do is a big thank you to Allan and Toby for your introductory statements. We are going to kick it over to the other side. Anthony, I'm going to give you the floor, and we're doing 8-minute introductions. And just to remind everybody, we do Q&A at the end of the show, and super chats are read with priority. So get your super chats in, and those will be promptly read. So Tony, the floor is all yours.
Okay, I'm going to start with one basic thing. The shape of an object is independent of its motion. The geometry of an object doesn't change if it spins, doesn't change if it moves backwards and forwards. So all of this talk about motion, completely irrelevant. We should consider the evidence that relates to the shape of the Earth. Let me share my screen.
Ready when you are.
Okay, so we have two potential models. We should be comparing both. I noticed that what my interlocutors failed to do was demonstrate what should happen on a flat Earth. They only considered what they imagined should happen on a spheroidal Earth and then get it hopelessly wrong. So we should compare the expectations for these two. And if one fails to meet predictions, it should be discarded. You don't win a weightlifting competition by saying, yes, we can do that. You have to actually lift weights. Let's look at a real world example. I have 2 points on Earth's surface. I want to know what the distance between them is and what bearing I should follow to get from point 1 to the second. This should be, on the flat Earth, a very easy geometric calculation. We know the angle between the two rays. We know the distance of both points from the North Pole. It turns into a standard triangle. We can use a plane triangle formula. If you believe that, this is your flat Earth map. It turns out to be the same on a spheroidal Earth, except that we're using a spheroidal triangle formulation. We get this formula. We can now test them, and we have been testing them for more than 300 years. Here, for instance, is the lifeboat sailed by Captain Bligh, more than 7,000 kilometers. He had to calculate exactly how much food and water he had in order to get from one point to the other. He did it accurately, and we know he used spherical trigonometry to do that. A similar case was observed in the early 20th century in the Shackleton expedition, which got trapped in the ice near Antarctica, and in the end they had to sail, Shackleton and 4 other people had to sail a lifeboat 1,500 kilometers in order to get to safety. We have thousands of daily experiments. Each ship that sails on the ocean calculates its distance using the spherical distance formula, calculates its heading using spherical trigonometry. Here is a 17th century sailing manual that considers the problem of how to navigate from the mouth of the Amazon to the island of Lundy, and it does it demonstrably using spherical trigonometry. Flat Earth cannot solve these problems. There is no flat Earth technique for doing this. So flat Earth loses. We have compared the two models. We have compared their ability to do this. The same goes for aircraft trajectories. Here, for instance, we can calculate the distance for these 5 flights. What I've done is I've averaged the outgoing and ingoing flight times in that 4th column. I've multiplied that by their average flight speed to get the maximum distance. I have allowed nothing for negotiating air traffic or getting to cruising altitude. That's that 5th column. The next column is the spherical distance estimate. You will notice that the spherical distance estimate is always smaller, but comparable to that maximum distance. The flat Earth estimate is in the final column and is in error by up to 106%. I've highlighted them in red. We can do the same with submarine cables. We have submarine cables connecting different points on Earth's surface. We can calculate their lengths. We can compare them to the spherical distances. Well, actually, we don't calculate their length. We can measure their length because we know how much this should be. The flat Earth distance is longer than the cable. That's impossible. And, you know, there's a difference here of several thousand kilometers. These submarine cables, in order to lay them, cost $3 million per kilometer. So this is $6 billion of cable that is somehow missing. Who paid for that? We can look here at another cable going from Australia to Oman, and we get the same problem. There are lots of these. These are measurable physical objects. We can look at train tracks. Here we are in Australia, the train track between Kalgoorlie and Takula. The track separation is 1,280 kilometers. The spherical distance is 1,242. Flat Earth tells us that they should be 3,000 kilometers apart. This is something we can go and measure. This is something that people travel across. This is not some esoteric philosophical prattling about experiments that my interlocutors have completely failed to understand. We can do a comparison between this and Jacksonville, Pensacola. We can work out the spherical distance. We can see that we can measure the track separation, and we can look at the flat Earth distance, which is again too long. It's worth pointing out that these two lengths of track are an equal distance north and south of the equator, and it's well worth noting that at both times the distance per unit longitude is the same. We can test. The flat Earth model tells us that a fixed band of longitude should increase in length the further southward you go. The spheroidal model says that it shouldn't. It should shorten again as you approach the southern pole. We can go back here. We've got a northern hemisphere and a southern hemisphere. If we just treat the track lengths as though they correspond exactly to longitude, which they roughly do, we can see that the northern hemisphere longitude step is larger than the southern hemisphere longitude step. This should be impossible, but this is a physically measurable thing in the real world. We can go to Argentina, even further south, and we can see that east-west tracks get shorter. So again, the flat Earth has failed to predict what we can measure to be true. If we take a solid ball a solid ball of steel, for instance, and we can introduce a vibration, we will observe that the surface vibrations travel like this. They go from the top pole where the vibration was applied down to the south pole. Let's look at an earthquake. On the left here is an azimuthal equidistant projection above the epicenter of the Macquarie Rise earthquake of 2004. On the right, we see the flat Earth map for this. Let's watch how the energy projects out. Those blue dots are the ones where the most recent seismic arrivals. You can see on the left that it moves out in a roughly circular fashion. You can see that on the left. On the right, it's spreading out in some sort of mess that doesn't make any physical sense whatsoever, but it will do in just a moment. We can see that the energy spreads out in a circle. On the right, we can now see that it is converging in a circle on the right-hand side. It is converging circularly on a point opposite to the epicenter. This is exactly what we should expect to see on a spheroidal Earth. This is utterly unexplained by any existing flat Earth model. And
10 seconds.
How much?
10 seconds.
10 seconds. Here is the P wave shadow zone that my interlocutor was so concerned about. You will notice that there are no P wave arrivals. And then all of a sudden they come in at once. This is observational data. This is real stuff measured by instruments.
All right. Well, thank you so much for your introductory statement there, Tony. We're going to kick the 8 minutes over here to Darryl. So thank you so much for being here, Darryl. And the floor is all yours.
Awesome. So a moment, I'll get the screen share started.
Sure thing. I'll just hold the clock.
And am I good?
Not yet. There we go. It is up and running, and I'll start your timer right now.
Awesome. So hello, everybody. My name is Darryl Lee Berry Jr. Some of you may have known me. I was debating this topic on this show a few years ago. I actually live in Austin, Texas. I'm an undergraduate student in physics and astronomy, so it's a pleasure to be here, partnered with PhD Tony, because I want to be a PhD, so I'm a big fan of his and the patience he obviously has to even have this discussion with all the stuff he obviously knows. The more I learn about physics and astronomy, the more I see how ludicrous the flat Earth argument is. It's amazing that he has the patience to do this. So I'll go ahead and present my points about some of the ways that we know the Earth is a globe. Looking at these debates as well as researching them, I find there's so many different ways, but I'll pick mainly two. These are the references that relate to the different things I'll show. If anybody wants to click back and check them out. And the two things I'll focus on are basically the people and cameras that we have in space and looking to the sky. So basically, these are ways that we know in various contexts that the Earth is a globe. So some of the pictures that we'll look at about people and cameras in space, to give you a brief preview, we'll start with the ISS, which is one of my favorite things. Basically, it's a spacecraft that's orbiting the Earth. At about an hour and a half, it takes to go all the way around. And this picture in particular was taken by the Endeavour crew on this last flight to the ISS. This is that crew right there. They took a picture of it as they were leaving the space station. So the fact that we have people out in space that's orbiting the Earth, I mean, that's pretty conclusive that the Earth is a globe. This is another picture taken by an astronaut. Basically, it's the area out around the Caribbean. Puerto Rico, Cuba area. They call it the Hispaniola area. An astronaut took this picture, and as you can see on the left, we don't see like an ice wall in the back or anything else that people are talking about. We see, a nice globe that's curving. This is from earlier this year, the Guatemala wildfire. This picture was taken by an astronaut aboard the ISS. So I thought it was pretty cool. So we have that going on a regular basis. They constantly going around the Earth, and we could look up and see the ISS and things like that. If you want to have a look at a timeline of the different observations that we have from space, there's a collection of the different satellite photos and people who we had on spacecraft that took pictures of the Earth or pictures of various parts of the Earth. So if you want to check that out, it is a pretty good thing to check out. The next thing I'll point out is looking to the sky. And I'll spend a bit more time on this one. So basically, the idea is that we look up at the sky, and because PhD Tony is right that the shape of something is different from whether it's moving and not. A basketball sitting on the ground is a sphere, whether it's on the ground or you're throwing it into the hoop. Well, yeah, we can still determine that the Earth is a globe as well from looking at what's going on in the sky. Either, I don't know if the proper word would be determine or infer, whatever you want to call it. But one example would be simply the fact that the model that we have, we can predict where the planets will be. So for instance, this is an image of Mars with one of his moons going around it. This was actually taken by a satellite. I can't recall which one. That took a zoom-in picture of Mars and the moon going around it. And basically, this is one of the planets that you can go to timeanddate.com or various websites, and we have all these motions plotted to precision with our understanding of the Earth being a globe and all the planets being spheres revolving around the sun. This is another one of Jupiter. This was actually taken by Voyager on its way to Jupiter back in 1979. And you can see the red spot. You can see three of the biggest moons, Io, Europa, and Callista. And that's another planet, of course, that you can look on various places online. We have all of these rotations or revolutions plotted precisely with Kepler's laws. We know where they're going to be. And, you could just go online and see exactly where they're going to be. Look up and point your telescope there, and you'll see it there. And here's Saturn. I actually saw this one not only on my own telescope, but where I'm originally from in New Orleans, there was a guy in the French quarters. A lot of people do various things there to make some money. And he had his giant telescope out there, and I was able to zoom in really close on Saturn, and it was pretty cool. So the fact that we have models based upon this and precisely can see where they at, the models, the predictions never fail. Shows me that our model is correct. The last thing I'll look into is actually solar eclipses. So this is a solar eclipse from August 2017, one that I saw myself when I was living in Kentucky at the time. And we have a clear understanding of what causes solar eclipses. You have the sun, you have the moon, in between the Earth and the sun, and the shadow of the moon comes upon the Earth. And of course, we have another one coming up soon on April the 8th, which I plan on seeing. Ironically, I'm living in Texas now, and this one is coming right in Texas. So that'll be the second one I see. So now I have a solar telescope. I'll take pictures of it as well. But one thing I want to point out is, if you compare these two solar eclipses, if you look at August in the Northern Hemisphere, we're about departing summer. So the angle of the tilt of the planet is a little bit past the sun. And if you look at April, we're approaching summer. So the tilt of the planet is a little bit to the left of the sun. And you can see that in the shape of the path of the solar eclipse. You can look at the shape of the path of the shadow across the Earth and compare what that shadow would do on a sphere with a little shadow moving across it, and it matches. So, and that's why you look at all the different paths of the solar eclipse, and you compare it to where the tilt of the planet will be relative to the sun at that time of the year. It matches the orientation of spheres revolving around spheres. Another thing that we notice with solar eclipses is they match the phases of the moon. So that picture at the top is a picture I took.
1 minute.
And thanks. And you can see the January uh, uh, depiction on that little phase calendar, we're heading towards a half moon, and it matches that. So if you notice, a solar eclipse is always when the moon is in a new moon, because the moon is in between the Earth and the sun. So all of these things line up. So that's pretty much what I had to discuss, except for the fact that, of course, Flat Earth has none of this. They have no predictions of a planet star, no predictions of eclipses, no locations, no path, size, no duration. Of course, the globe has all of that. The images they have of the planets, either they're unwilling or unable to utilize, telescopes and cameras properly. I'm sure you've seen the things where they show like it looks like it's underwater. But anybody who ever takes their own telescope out, you see that it matches what NASA shows. That's pretty much my presentation. People and cameras in space and look into the sky.
It's time.
And I hope you all enjoyed it.
Thank you so much for your introductory statement there, Darryl. We are going to kick it into an open discussion, and admittedly, sometimes it can get a little tough back and forth, so if we have to move into muted rounds, then we will do that, but we're going to try to keep it as open as we can. Once again, hit the like button, and if you like what you're hearing from any of our speakers, if you're listening on podcast right now, all of these debates are uploaded to podcast form within 24 hours, so definitely check us out on your favorite podcast app, and if you're listening on a podcast app, check us out on YouTube, hit the subscribe and hit the bell so you don't miss these live events. So let's put it back to the other side to respond to some of what you just heard, Toby and Allan.
Sure,
Awesome.
yeah. You can go ahead, Allan.
Yeah, so I seen in Tony's presentation, there was a lot of references to different flat Earth distances that didn't match out to the globe. I was wondering where you got your flat Earth distance predictions from, because all maps that we have available are just equidistant projections of the globe, right? So are you taking different globe projections and then saying that the distances don't match up and therefore like there's a flat Earth discrepancy? We actually
I
don't.
explained this in my presentation, but if you want, I can reshare. So
Yeah,
there
just real quick.
there are two axioms, and there are two axioms that go into this distance calculation. One is that if we know the latitude of a point, we know
Right.
how far it is away from the North Pole.
Mhm.
And the other one is that if we know the difference in longitude between 2 points, then we know the angle between two lines.
Mhm.
As long as I have those two pieces of information, I can calculate the distance between them on a planar triangle using the cosine rule. This is just the planar cosine rule for a planar triangle. This is simple 8th grade geometry. Okay, I'm not using anything about the globe. So if you're going to argue that my estimates are wrong,
Well, 1 second. Are you using what longitude and latitude system are you using, sir?
there's only one longitude and latitude system, sir.
That's the globe, sir. So you're taking globe.
Yes. So
Yeah.
if you want to, so what you're saying is that a navigation and location system that works extremely well and is utterly reliable cannot be used with these axioms as though the Earth is flat. So
Well,
which
actually-
of these is wrong? Which of these
Well,
is wrong? Are the positions wrong?
Well,
Are
one
the
second.
distances to the North Pole wrong, or are the difference in longitude wrong? Which is wrong?
Before we get to that, let's address the flat Earth predictions that you're doing. You're using the globe longitude latitude system. It's going to output globular distances. You're not going to get a flat Earth distance out of that, buddy.
Please provide the correct flat Earth model and I will implement it. I can implement it real time.
So here's the thing. I don't have that.
You don't
for
have
you.
one? The dog ate it?
No, it's called, go to adl.place, click on Shane's flat Earth model, right? And then we're going to go over the 69 miles per degree, right?
Yes. This is
Yeah, there's
the,
an
this,
important.
so
You're
this
talking
ought to
like
be, but in order for that to work, okay. So this formulation here is exactly that. This is the spherical distance formulation. So what
Yeah.
this does is it calculates the angular separation between the 2 points, and then it says, okay, it's 69 miles per degree of separation. That's this formulation.
Yes.
Okay. If you want me to do that, tell me how to get the angular separation between points on Earth's surface that isn't from spherical trigonometry.
Listen,
Okay, this is derived from spherical trigonometry. So if you're saying 69 miles per degree of separation, that's spherical trigonometry.
All right, I think Toby had a thought up there. Did you want to jump in?
Well, yeah, I would go back to like a slide or two back. He tried to talk about like this whole thing's based on a crazy assumption. He's talking like these angles, these are reliable in all points of reference, but that's not the case. You know, even for a celestial navigation, that
Please
relationship
prove that point.
that please don't interrupt me. That relationship's not purely linear. And
Please
actually that's
prove your point. Don't
well,
just
I
tell
actually
me.
showed
Don't
okay.
just tell me something. Show me your evidence.
Well, I did show you a couple of papers in my opening talking about curved visual space and the way that we perceive
This
things.
has got
in the
nothing to
distance.
do with visual space, mate.
Just 1 second there, Tony. We'll let him wrap up his thought. So 15 seconds there, Toby, and then we'll let you have your thought there, Tony, sorry. Toby
Sorry,
and
did you say
Tony.
Tony or Toby?
Yeah, no, this might get tough. I'll try to say Anthony. Sorry, Tony. Just to try
That's
to
okay.
stay from confusion. So 15 seconds, Toby, and then over to Anthony.
Yeah, you asked for a model. You know, we actually literally did model it out. And like I said, it's not a linear relationship and it wouldn't be a linear relationship. So the fact that you're acting like you should expect a linear relationship shows that you don't actually understand how it should work on a flat Earth model and how perception necessarily works.
This has nothing to do with perception, though, does it?
But it does, because you're always going to be taking an angle out from a single point, correct?
No, I can get my latitude and longitude from GPS, right? There's no
And how
human
are you
perception. There's
calculating
no
your angle?
human. You asked for me not to interrupt you. There is no human perception involved in radar triangulation.
Coordinate triangulation. Are you familiar with the arc of the parallel?
I was still in the middle of speaking.
Right.
You're the one.
Hey.
You're the one who got chirpy about being interrupted.
Hey, pardon me for trying to be conversational. Go ahead.
So there's no human perception involved in GPS, is there?
He's passed
Well,
the floor, guys. So
if you-
let's
yeah,
go
if
into
you
a
would-
time.
If you would like to get into GPS for confirming the coordinate system, it's actually not going to help you because GPS has meridian corrections built into it. So it's going to output exactly the globular coordinate system. Now, the reason we're talking about perception and all this right now and the optics, right, is because that latitude and longitude system that you're adhering to, that you think is a linear relationship due to Earth curvature with 69 miles per degree and all that, we actually have the curved visual space math for it. We can show that there's a logarithmic relationship with how we see and how this coordinate system is derived. So 1 second. So when you're comparing different distances on a globe, right, all equidistant projections of the same thing on the same coordinate system, it doesn't mean anything.
So why is it that anything that travels, say for instance weather systems or earthquakes or tsunamis or air pressure waves, why do they all travel in a uniform ring out from their focus under the spheroidal coordinate system? Why is the physics of wave propagation suddenly different in order to accommodate a flat Earth geography?
Well,
I'm
actually,
glad that you
Go
asked.
ahead, Allan.
Well, I was going to turn it over to you. I was going to say I'm glad you asked. Toby,
Sure.
Toby can
No,
talk to you
I
about
wouldn't
the
mind
flat
resharing
Earths.
again real quick here.
Sure
Let me go ahead and pull up my presentation again.
Yeah. When I do that, I'll remind everybody that we will be doing Q&A after this, and I do want to get Darryl in here to respond to what you're about to share, just because we haven't heard from you, I think, since we started. So let's get you in here. So Toby, once you got your screen share up there, and you want to make an argument, and then we'll let Darryl respond.
All right. So, yeah. So just like, first of all, your chart that you showed, so this is not necessarily relevant for the screen share, but the chart that you showed is kind of crazy because I would think that you would know better than anyone that there's tons of anomalies within those datas. Like there's, I can pull up you had, what was it? Valdivia earthquake in 1960, 2004 Indian Ocean tsunami. The Valdivia earthquake had the detected locations as far away as Europe and Africa. Basically, the things were detected out of order, right? The phenomenon was attributed to unique propagation of seismic waves through Earth's mantle. And then in 2011, there was that Tohoku earthquake and tsunami, and that was a magnitude of 9, and that triggered a powerful tsunami. And the seismic waves from that were detected at locations as far away as the west coast of the United States and South America before they reached some of the closest Japanese islands. So there's all sorts of anomalies within it. And to try and straw man the flat Earth on that is crazy, because you're not even like going into detail about what flat Earth model you would use. There's like a million different possible ways you can compute that. And on the topic of computing that, so this is what they actually do, right? The 2D, 3D multiplied, transmitted, converted, and reflected arrivals in complex layer media with the modified shortest path method. And so this is showing they use a multi-stage scheme, and they treat each layer that the wavefront enters as an independent computational domain.
Feel
One
free to
obtains a
jump in.
transmitted. What's that?
I was just telling the other fellas they are free to jump in at this point,
Oh,
because
yeah.
we've given
Gotcha.
you the floor quite a bit.
But it obtains a transmitted and or converted branch of layer arrivals by reinitializing in the adjacent layer, and a reflected and or converted branch of later arrivals by reinitializing in the incident layer. So they do this for they do things for computational efficiency. This is all based on computations. This is not measurements. And this is showing here, this is doing benchmarks. They use a one stage MSPM. And it delivers the same solution accuracy under less CPU time than the regular SPM. Then what do you know? That's actually going 2D versus 3D. And the code of multi-stage FMM is in Cartesian coordinates for 2D models and spherical coordinates for 3D models. So this is all based on computations. If we had the same type of supercomputer, we could easily do it with a flat Earth model.
Really? Because I happen to be an expert in flat Earth seismic models. And I can tell you that I'm still speaking, and I can tell you that we've done research papers on how far you can treat the Earth as flat, and the answer is less than 200 kilometers. On length scales more than 200 kilometers, your tomography falls apart and your arrival times shatter. So you trying to lecture me on this subject is particularly engaging. But I'd like to share a post now.
So what about the fact that in those papers they literally said if you just did a time differential, you could make it work on a flat Earth?
They're talking about sites that are less than 200 kilometers away from the
but then you just have to change your time.
Don't overtalk me.
Don't yell, man. This is just a debate.
Okay, don't overtalk me, and I won't yell.
You're conversating with me, and I'm conversating with you. That's
no,
how it goes.
You're interrupting me, trying to cut me off.
For no reason.
Just interrupt here. I'm sorry, gentlemen. But yeah, when you do raise your voice like that, Anthony, it is clipping the mic, so it does break the threshold of what I have.
Okay, but as soon so I just established that I've published in this discipline, that I've read heavily in this discipline, and while I'm trying to explain results in this discipline, this guy wants to interrupt me, and it's I don't think it's reasonable.
Let's forget the meta. Let's give you a minute.
So let's look at this. This is a plot of observations versus predictions. The earthquake, the waveform arrivals are shown as dots, and the model predictions are shown as solid lines.
Can I ask a question?
Yes.
How is this extrapolated out to a map?
You will notice that the angular separation is given down the bottom in degrees.
Okay, so are you using computations?
The dots are observations.
Based on what? In relation to what?
So the initiating event is at the origin, time 0, down the bottom. That's the bottom left-hand corner of the figure. The time at which the wavefront is detected at the for a seismometer at a given angular distance away is recorded as a dot.
Okay, so you have some computations. Gotcha.
There are computations, yes, but you seem to have missed the part where there are observations.
I mean, I already kind of clarified, right? We can compute this on 101 million ways, especially if we throw more computational power.
Okay, no, you can't. No, you can't, and I'm
Yeah,
about to demonstrate why.
Machine learning would be
because
one way.
because on a flat Earth, the distance that the wave has to. So in this case, the red dot is the epicenter. The black star is the focal event. you can look at the surface distance between the epicenter and the receiver, which is the white circle, is the same in both formulations, in the flat Earth formulation and the spheroidal formulation. But you will see that in the spheroidal formulation, it has to travel a significantly shorter distance. Okay, and when you look back at the observations, what do you know? The average velocity that the seismic waves takes decreases as you go with greater angular separation. They seem to be arriving faster than they should. It's not just a linear extrapolation of distance, which it should be if the Earth is flat. So this set of data is completely inconsistent with a flat Earth formulation. And I put it to you, sir, that you have no training in seismology, that you have no training in geophysics, and that you are opining on a subject that you are simply unqualified to opine on.
So you're not going to be able to explain it to me because you actually can't explain it to me, can you?
I just did explain it to you, and if you, I just did explain it to you.
You're just going to gaslight me without any.
I just did explain it to you, sir.
All right, we'll give you we'll give you a couple seconds there, Toby. If anybody else has any other thoughts, or if you wanted to do a screen share,
sorry, I cut off Darryl again.
Oh, sorry as well.
And I'd love to bring up the papers that you brought up in your debate with Witzik, because I actually went through those, and did you understand the point that I made about changing the time differential to make it work on a flat Earth model? And they even said that in the paper that you brought up.
Yes, they did for local wavelengths.
It's literally in the paper. It's literally the part where they're talking about the discrepancy between the far distance and the short distance. So it's actually talking about that specifically.
And what's the conclusion of the paper, sir? The conclusion of the paper is that flat Earth models should not be used for distances over 180 kilometers, isn't it?
Change the time differential.
Yes, so time has to magically change, does it, sir? Is that physics?
Speed could change, right? And what is speed is a measure of time over distance, right? So actually,
no, speed is not time over distance, sir.
Oh, wow, you got me. Earth must be a globe. No, so if the distance is relevant in that equation, right? Then that must just mean that maybe there's a difference when you start going below the Earth's surface. Maybe you don't actually know. Maybe you don't actually know what the Earth is made up of. Please don't interrupt me. Maybe you please don't interrupt me. Please don't interrupt me. Please don't interrupt me.
Tony, I don't want to put you on mute. We got to let him finish his thought.
Maybe you don't actually know what's beneath the surface of the Earth. Maybe you're wrong about it. Maybe the speed would be a little bit different because your assumptions are all based on assertions of a bunch of magnetogeology, geology, sedimentary rocks that don't add up, a bunch of things that don't add up, that's all confounded on each other.
And you have an
iron core that doesn't even work with Newton's shell theorem. It's like violates the first law of gravity. It's insane.
All right, we're going to let Darryl and Allan in here. Sorry, Tony, just because we haven't heard from them.
I want to respond to that.
Tony is an expert on this stuff, so I would like to jump in on a different topic when they finish with this topic, but far be it from me to try to talk about seismology and earthquakes when Tony's here. So I'm fine with him handling this, and I want to talk more about Michelson and interferometry and stuff like that.
That time adjustment that you're suggesting is applied to the seismic stations. It's not applied to travel within the Earth. You are basically adjusting the seismic stations. That's what you're doing when you do that time adjustment. So you're saying that for some reason time doesn't flow linearly at Earth's surface. And again, sir, it's amazing to me that you're here arguing for flat Earth rather than the authors of the paper you suggest supports flat Earth. Why do you think that is?
Wait, so you want me now to go into the mind of the person that published the paper and talk about what their motives are in their life?
No, I want you to concede.
Is that supposed to edify the listeners of this debate?
I want you to concede that the authors of the paper do not agree with your interpretation of its content.
So do I also have to absorb their favorite color, their favorite food, their favorite ice cream too? Or if I disagree with that, does that mean that I must be wrong about everything that they say as well?
Well, let's take a particular example. You quote the Ally effect.
That's not how that works. Obviously, I'm being sarcastic, right?
Do you quote the Elias effect? The Elias effect is a deflection from the standard precession of a Foucault pendulum, which is compared against predictions based on a rotating Earth. So if you accept that the Elias effect is real, then you are accepting Earth rotation is real. So the idea that this pattern of you introducing a scientific result and ignoring the observations that underlie this scientific result is more general than seismology. And to me, it's a deeply concerning thing. To be brutally honest, it seems deceptive. It seems
can I have a
willfully
minute to
deceptive.
respond? He's calling me deceptive. Can I maybe respond, James?
Yeah. My name's Ryan.
I'd like to have like a good
says
minute without
James.
interruption if possible.
Yeah, you get a minute on the floor. And we'll
Okay, great.
do
So I
the
love
same.
that you brought this up, right? Because this to me is everything. This is I can go into the ether wind now because that's what this is all about. The interferometry measures a correlation with the sun and the moon, the motion of the sun and the moon, and it varies by like 30%. So the rotation of the Earth is not getting faster and slower by 30% as the year changes. That's crazy. And and the Earth isn't rotating faster when you go higher at altitude. That's crazy. And what do you know? Interferometers, the measurements that interferometers make correlate with the same measurements that the pendulum makes. And you're going to try and invoke the fact that the pendulum rotates precisely in line with the rotation of the Earth. But if you actually go and look at specific experiments, you'll find that quite frequently it does not actually align with perfectly with the rotation of the Earth, and they have to make adjustments. And a lot of these museums that have Foucault pendulums actually have electromagnetic systems in place to keep the motor in place to keep things processing at the proper rate, because they don't want someone to come into the museum and suddenly, oh, why the Earth's not rotating today? That's crazy, because they literally don't work as expected.
Okay, so what you're claiming is that Elias faked his results because he noted deflections from the precession, from the rotation predicted precession. That's his entire result. So if you're claiming that that's faked, then you're saying that Elias faked his results and then noticed a deflection away from his faked results. You're shooting yourself in the foot. And
No.
It's 37 seconds.
Also, this claim about the Sagnac effect. You understand that the Sagnac effect is not restricted to lasers, right? The Sagnac effect can be detected in matter waves, so they can get a cloud of a super cool cesium in a Bose-Einstein condensate, propagate it both ways around a circuit, and look at the interference. So you're aware of that research, are you?
It's in neutrinos too. Yes, we are.
Yeah, Ruyang Wang did an experiment with it in 2006, or no, that was matter wave interferometers was 2012, I think. But yeah, Ruyang Wang did an experiment with it and found that it was the exact same thing.
And electrons.
He even proposed
so
a linear
how does
motion
ether?
detector
Just 1
with
second
it.
there, Tony. We're doing time, so he's got 45 seconds left, unless he wants to cede.
How does ether affect the how does ether affect Schrodinger's equation?
A really random question.
No, because matter wave interferometers rely on the propagation of Schrodinger's wave for a Bose-Einstein condensate. That's how the interferometry is measured. So if you're saying that this is due to ether wind rather than, for instance, Earth's rotation and motion, then you're saying that the ether is having an effect on Schrodinger's equations. What is that effect? How did you demonstrate that? And how is it quantified?
So the fringe displacement that's measured in the matter interferometry, neutrino interferometry, electron interferometry, regular electromagnetic interferometry, right, is all in regards to the ether wind relative to the latitude. So how they're describing quote unquote Earth rotation, right? It's the ether wind relative to the latitude.
That wasn't my question. My question is, how does ether wave affect Schrodinger's equation?
It's a wave equation, my dude.
Yes. So what? Show me where in Schrodinger's equation
buddy,
the ether is included.
Schrodinger's equations are based off of Maxwell's electromagnetic theory, which is based off of the ether anyway. So you're
that's not true.
Yeah, it's 100% true.
No, it isn't.
It's 100% true, and by invoking it, you're
not
doing anything. Okay.
If I can jump in on this topic for a moment, because I want to actually, this is one thing I wanted to talk about, because I noticed that both Toby in this debate here, you mentioned Michelson molding interferometry. And I saw a little bit of your last debate, maybe not your last debate, but one of your previous debates, Allan, and you mentioned it too. So it sounds like you both are saying that the Michelson molding experiment was to show that the Earth is not moving. Is that correct?
So they were trying to measure the motion of the Earth, right? So
Nope.
if they were, the title of the
paper's
paper,
literally
let me
called-
actually take this one a bit, Tony. I want to
Yeah.
actually discuss this one with him a bit. But what was that?
Absolutely, brother. So the title of the paper is, let's see, it's on the relative motion of the Earth and the luminiferous ether, right? So
And actually, I can load it right now. But perhaps you can point out to us in the page, like where in it is it saying that they were measuring the motion of the Earth?
Okay, scroll. Okay,
Are you able to see it?
yeah.
Hold up.
Let me screen share. I have
let
it
me
all
try-
highlighted. I can bring it up for you
Sure.
immediately.
Okay, go ahead.
Give me
Remember to
1
warn a
second.
fellow
Title,
before you
first
screen
sentence.
share.
Oh, sorry. I'm going to screen share in about 2 seconds.
Okay.
1, 2. All right.
And I'll also
Should be-
pull up while he's doing that. I can pull up Albert Einstein saying that that's why he devised special relativity.
All right. Is it on my fuck? Is it on my second monitor? Or can you guys see it correctly? Never mind. There it is. We're good.
We're seeing everything on there. There we go. The American Journal
right.
of Science.
All right. Here.
I
All right.
think
Here
I
we
can
go.
see it.
All right.
Okay.
Here we go. So, right here, they're giving their derivation for how they're going to measure the velocity of Earth. So we have v, little v, d, t, and t. Right. So we got v for the velocity of light, v for the velocity of Earth. The two time differentials here, when they reduce the equations down, they have 2d over v squared, right? So the velocity of Earth over the velocity of light. That's how they're deriving their proportional relationship with the fringes. Now, when they get down here to what they actually measured, oops, 1 second. When they get down here to what they actually measured, they had a prediction of 5 fringes, which was going to correspond to 30 kilometers a second. They measured a little over 1 fringe, which corresponds to about 4 to 6 kilometers a second. Now, depending on who you ask, you'll get some fluctuations within that, but it's about 4 to 6 kilometers a second is the accepted value. So what we have here on this ending page here, page 5, they say that.
So one moment, because I want you to specifically show, because like for instance, look at that part right there. Yet you have in green. It says, and what proceeds only the orbital motion of the Earth is considered. And this is combined with the motion of the solar system, concerning which but little is known with certainty, the result will have been modified. So this is clearly saying that from their perspective, the Earth is moving, the solar system is moving, and they're measuring that with relation to something else. What you're saying is not matching what the paper is saying. It's right there. You could also go to, let's say, the last page. Go way to the end, all the way to the end. It says finally, finally,
on Lorenz's notes, yeah.
Finally, there remains a determination of the velocity of light by observations of the eclipses of Jupiter satellites. If the improved photometric methods practiced at the Harvard Observatory makes it possible to observe these with sufficient accuracy, the difference in the results found for the velocity of light when Jupiter is nearest to and farthest from the line of motion will give not merely the motion of the solar system with reference to the stars, but with reference to the luminiferous ether itself. So clearly, their premise is that the Earth is moving and the solar system is moving, and they're measuring it in respect to an ether. So what you're saying is not matching. I want to look at something else, because one thing I'm noticing is for you to speak, it seems to me that how you're talking as if you understand this stuff. So let me ask you, would you go to page 336? You were talking about the equations, right there, a little bit farther. So on the line where it says neglecting terms of the fourth order, would you tell me what that means? What do they mean by that?
Exacting terms of the fourth order. Where you at? Where do you see that at?
Your mouse is right there, a little bit higher. It says 2D V over V, a little bit higher, a little bit higher, a little bit higher, right there.
Oh, okay.
Neglecting terms of the fourth order. What do they mean by that?
Neglecting terms of the fourth order. So, not sure.
You don't know. So you have
Would
no
you-
idea what the hell you're talking about. You're talking
Would you
about
like
these
me to
equations as if
answer?
you know what you're talking about, but you don't.
You can answer. But
Let me ask you this. What
okay, hold on
order
1 second. 1
experiment
second.
is?
One
What?
second. 1 second. Tony, you can go ahead and answer real quick. What is?
Okay,
What is
so-
Hold
the,
on. I
what is
asked
the-
Tony, let me go ahead and have this. I don't want him to run away from this.
Oh, I'm
yeah,
not running.
don't
bro.
know what you're talking
I'm not
Objectively,
running. I want
Tony's
the
you
got.
sit-
answer-
Yeah, Tony
I want the
can hold
answer
his
to the
thought. I'm
fourth area.
sure.
So-
You
so
know,
good.
he
Sure.
Yeah, because I let him have the whole seismic thing because I wanted to get this. You were sitting here earlier saying this is T, this is what they're measuring. You don't even know. That is a simple mathematical understanding. That's the foundation of understanding these formulas. If you don't know that, clearly you have no idea what they're talking about. Let me ask you this. This experiment, what order experiment was it? What order
So
experiment is the Wilkinson-Morley experiment?
they say that it's a second order experiment. It is actually a first order experiment because in 2004, the Sagnac effect was linearized. So the fact that this
Hold up. So that answers the question. That answers the question. I don't want you to run away. One moment, because this is what I found.
It's a first order experiment.
All right, let's let Darryl
So
clarify
tell
his
me
question.
what that means.
What that means
Tell
is
me what that means.
you can find a direct proportional relationship to what's being measured.
And I can tell
Say
you
it
right now,
again?
I don't care about the order.
You can find a direct proportional. What does that mean as far as the equations?
It means,
what is it that's happening in the equation?
Bet. So right here, the velocity component, right? This is what they're trying to measure, right? So that's the that's what they're measuring, bro.
You have no idea what you're talking about. What this is talking about is actually a Taylor expansion. And when you Taylor expand, every single order of the expansion has a different power on the exponent of the expansion. So they're neglecting everything above the third exponent of the third expansion of the Taylor expansion. You have no idea what you're talking about.
Bro,
Therefore,
listen.
you don't understand what this experiment is. So everything, both, Toby, did you understand that? Do you even know what that is, Toby? You mentioned it as well. Do you know how to do a Taylor expansion?
No, I don't need to understand the direct proportional relationship of the Sagnac effect.
So you don't
of
understand
C
what
plus
you're
or
talking about
minus
either.
V.
No,
Darryl.
Darryl.
Just one second, Darryl. You did ask him a question, Darryl.
You've been talking for a minute, bro, about how we don't understand.
Just one second there, Allan. So before Toby
getting off your chest, we can proceed.
Just one second, Allan. Before Toby loses his thought, over to you, Toby. And I just asked to give the floor to Toby.
Gotcha. Yeah. No, I mean, it's just, I don't need to understand the fourth order stuff at all. I don't care about the fourth order stuff. I'm more concerned with first, second order, right? And especially in the case of understanding the motion, they're going to try and derive things out to fit it into an orbital motion, but that's not, like you're trying to say that because these guys have a desire to make this fit within their their heliocentric model, that means that I have to have that same desire in order to look at their first order and second order measurements. That's crazy. That doesn't make any sense.
No.
Please don't interrupt me. And then also just in general, right? Like you can look at Ruyong Wang's math from 2004. Right now we're looking at a paper from 1887. So, if you want to pull up Ruyong Wang's 2004 generalized Sagnac effect, he does a really good job of going through the math in that paper. And he actually shows that it's directly proportional to the ratio of V plus or minus, C plus or minus V is directly proportional relationship. And what do you know? It's not just a rotational vector. It's a linear vector, which you guys still have not responded to. And I have a feeling that you're not going to provide a substantive response to that.
We do have to give them a chance to get in here because that would have been.
But yeah, just the point being, I don't need to know what they're talking about with fourth order there in order to understand the first order Sagnac effect, C plus or minus V, and how that directly violates page 1 of special relativity.
All right, over to you, Tony.
Okay, there are two things here. There are actually three things that I want to go on. Special relativity cannot have been violated because it has been observationally validated.
Oh yeah.
The decay rates and energy rates of particles in particle accelerators, like the Large Hadron Collider, agree exactly with special relativity. Special relativity has been observationally validated millions of times. So to claim that you based on your understanding of the Sagnac effect have discredited or undermined it is frankly nonsense. Observations are the kings. We've observationally validated special relativity. Give it up.
No, I mean, I substantively brought forth multiple papers. I cited the exact math that I was referencing. And then, it's funny, you act like this is like such a simple, straightforward thing. But when Einstein put forward special relativity, a whole board of scientists came. It was like a whole fissure in the scientific community because everyone knew it was utterly pseudoscience, but it was forced upon the world.
All right, let's.
You're missing the
show you a
part.
paper. I can show you a signed paper of 100 prestigious scientists that were coming out against relativity.
I don't care. What I care about are the observations.
Yeah, like when they tried to measure the orbital motion of the Earth and didn't get any.
You asked me not to interrupt you, and now you're just being a prick about it.
Okay.
Please don't do that or put yourself on mute. I'm going to go back. Special relativity has been observationally validated millions of times. Do you concede that to be the case, yes or no? Are you just denying
Absolutely not.
reality?
I'll just end the screen share. if
I
you don't
went
mind.
looking for it and
Just
I
for
couldn't
now.
find it. So no.
Okay,
No,
well,
don't
have
end it
you
because we're going to
looked
come
at...
back to it here in a second. As soon as these soon as they're done wrapping up.
Okay, just let me know when you're ready.
I want to ask another
Gotcha.
question. I really do want to ask another question. Can I share my screen for a moment?
Yeah.
I
apparently
think that
not.
would be fair. Yeah,
No,
let's-
you're good. You're good. You're
we'll do
good.
that.
Go
That's
ahead.
fine.
Give me 1 sec.
I got you. All right, go ahead there, Tony. I'm quick with that.
Okay,
I've had to be.
why aren't we talking about this? Here we have 2 lengths of railway track that are measurable. They are physical things. They completely destroy the possibility that longitude bands get longer as you approach the South Pole. So this is direct, measurable, observational evidence that the planar geometry is impossible. How do you just gloss over this and say that my understanding of the Sagnac effect is such that this doesn't matter? It's just not important. We'll go on and we'll disagree with all the scientists and their interpretation of the Sagnac effect. We'll disagree with all of the observational validation of special relativity, based on our limited understanding of these papers. But here's a test. Here is a measurable physical test. Why is this not important?
All right, because nobody cares about the geodesic arc links that are derived from the celestial sphere in the sky. So can we
This
get
is
back?
measurable.
Great. Can we get back to Michelson-Morley? And Darryl, I want to say
No!
much respect, bro. I love that you brought the heat on Michelson-Morley. Let me know when you're done, Tony, so me and Dude can get back to Michelson-Morley.
Okay,
Yeah, I have,
well,
I have
full
more
circle.
heat
let me
to bring,
ask
so yeah, let's
Darryl.
get back to it.
We can come full
Let me
circle
ask
eventually.
Darryl, don't you think that this is, sort of what I disagree with about Michelson-Morley is that it is completely unrelated to shape, right? It doesn't tell you anything about the shape of the Earth, even if we accept what these people say about it. It doesn't, it is based on an esoteric discussion about the contents of scientific papers. And with all due respect, these scientific papers are not written so that you guys can understand them. They are written for the benefit of other experts in the field. And the
gaslighting.
cherry picking that you do,
Yeah, can you wrap
picking
this up? Are
phrases
you
out
done
of the
gaslighting
freaking-
us yet, or what? Or do you have some more stuff you
picking-
want to get in?
All right,
Do
just
you?
1 second
Yes,
now. We
there
will
is.
give them-
That's why I'm still talking, mate. You can tell I want to keep talking by the fact I'm keeping
All
talking.
right, Tony, we'll
But
give
if
you.
you
Yeah,
want
but
to
you're just
interrupt me
gaslighting.
and
Though.
make
Are
me
you going
talk
to say something
longer,
of
keep
substance,
on
or are you just
going.
going to gaslight?
All right, we're going to give Tony 15 seconds to wrap up, and then we'll let you guys respond to some of the things you've heard.
Okay.
Thank you.
Mainstream scientific papers are not written for the benefit of the layperson. They are written for the benefit of experts. And your interpretation of their contents is basically disconnected from observational reality.
Yeah, so just real quick, I can try and respond to that. You guys heard him just trying to essentially tell us that we're not allowed to have an opinion on this because we don't have a PhD like him. But I looked at the papers, I read the paper. You guys looked at the paper with your own eyes. So for the edification of the audience, hopefully you're not being gaslit, because that's all he just did was gaslit literally the entire audience there. But to talk about why relativity is important, it's because, like I showed earlier with the Venn diagram, the ether wind's at the center of everything. And if you actually show that there's an ether wind that has a higher velocity at altitude, and changes with it correlates with the motion of the sun and the moon in the sky. If you can show that substantively, then you have a really, really, really hard time making that work on a globe. Especially
Can you prove that an ether exists?
Especially within the framework of special relativity. And I internalized special relativity growing up. I actually believed in the twin paradox. I actually thought that, if I went out in space and I left my twin, that if I actually was able to achieve space travel at some point in my life, that my reality would age faster than me behind me, and then I'd come home to a ruined world. So the idea of exploration is just nonsense within the Einsteinian paradigm. It's crazy how it just makes you nihilistic, isn't it? But yeah. So in any case, the ether wind's at the center of all this. And then as far as your thing about Australia, and about the distances there, I would just like to say, maybe you don't understand, but all maps, all of the globe is based on the King's Decree, the idea of, we have to follow this specific longitude and latitude
Feel free
system.
to jump in.
Everything is mapped to the sky. Everything is based on angles to the sky. And so the fact that your globe model, which is based on angles to the sky, aligns with itself is not impressive. And if I were to go out and take angles to the sky and map it to a flat Earth map, I would be able to produce the same result. And I would hope that you wouldn't deny that.
Except you haven't.
In sense.
Except you haven't. Except you can't.
Oh,
You
so
can't
that means that it's not
navigate.
flat
You
because I
can't
didn't go and
calculate
plot it
distances. You
myself?
can't. Okay,
Just 1
you
second.
talked for a long time and you overran your time, and I didn't interrupt you for a long time. So now we get to talk. You can't calculate distances. You can't calculate bearings. You can't do celestial navigation properly. You can't make GPS work. There's lots of things Flat Earth can't do, except apparently prattle about the Michelson-Morley experiment, which you're very good at. Off you go.
Tony, and I'll jump in here. And Tony, you actually make a good point. And obviously, as a scientist, you know how to get straight to the heart of the matter, calculating distances, which they can't do. One reason why I find this topic interesting is because, like, looking at Allan's debate, I was looking at him talking about this stuff, and clearly he didn't understand what he was talking about, like I just pointed out. And yet there were people in the chat saying, "Oh, that is killing them," because they didn't understand either. So that's why I want to go ahead and point out the fact that these people don't really understand the math that they're glossing over as if they understand it, which totally undermines not only their argument about Sagnac, but their whole argument together. This same understanding, or you should say lack of understanding, by which they present themselves as if they understand this more than the experts in it. It's the
Or
same
gaslighting.
understanding that they use on everything else. So that's why I want to focus on this. So what did you want to say about it, Allan?
I think about
Yeah.
50% of their argument has been gaslighting. Isn't that insane?
All right, cool. So we're back to the, what was it? The fourth order thing that you were describing here. So this was a, what did you call it? What was the name again, please?
It's a Taylor expansion.
Taylor expansion. Right. So when they get back down here, though, to this part where they're just showing 2dv over v squared over the velocity, right? What's that doing? What is that? Is that a first order or second order relationship that they're deriving with the velocity of Earth versus the velocity
I
of
hope
light?
you all behaved. Well,
I didn't do that, Matt. You supposed to
sorry.
have done the math because you're the one that brought it up.
Well, it's a simple question. You don't have to do any math. It's just the relationship that they're measuring right here, right? So when you say that this part is about the Taylor transformation, or sorry, what was it again? Taylor thing?
You don't even understand the basis. This is where I'm coming from.
Let's
back up.
No, you talked for a minute and gaslit the fuck out of me. So I'm gonna about how I don't know this
Actually,
shit.
y'all talked almost the whole time. I didn't really get anything in. So if you would let me actually get a little bit in.
We'll
I
do
mean, to
30
be honest,
seconds.
y'all had the floor almost the whole time.
Yeah, I want to
That's
give the floor to
true.
you, Darryl,
Why-
because
why-
I haven't heard much
Go ahead,
from you.
Darryl.
So go ahead.
You're
Yeah,
right.
exactly. So why don't we
Go
do this? Okay, both you and Toby brought up Michelson-Morley. In your first debate, your last debate, I would say you brought up the paper, Allan, by Wang, and Toby brought it up this time. So both of y'all apparently pushed that in to support this, and you both also say that this is a first order experiment. Is that right?
Well,
Okay,
he
why
derived
don't you bring up
the
the
first
Wang
order
paper
math.
for
He
us?
derived the first order math in 2006 using a phased conjugate mirror, actually.
Okay, why don't you bring up the Wang paper?
Derive the
Let me ask
math
you a few
using a
questions about
phase
that.
conjugate mirror.
Okay.
Nope.
One,
We can
one-
open that
one
paper
moment,
after
one
this
moment,
meeting.
You
Tony.
don't use
Go
phase
ahead and bring up
conjugate
the Wang
mirrors in
paper for us.
mathematics.
Or would you like me to bring it
Oh,
up?
you can't use them to measure a wave pattern the same way that it was
That's
reflected.
measuring a wave pattern isn't
And
mathematics.
actually, I
mate.
apologize.
Oh,
Y'all
you don't
might
use
not have this
mathematics
Wang
to
paper.
extrapolate the ratio of the frame shift?
You said he used
Wait,
a
so do you not use
conjugate phase
mathematics
mirror.
to calculate
You said he used a phase conjugate mirror to derive the mathematics. No, he
yeah,
derived
derive
the mathematics
to show the first order
for
measurement of the speed of light.
He derived the mathematics. You can try and talk over me to cover up your another.
I mean, it's not going to make the Earth more
egregious
globular,
error.
dude.
Yes.
All right, as fun as
but
this is, we don't want to
You are
derail.
constantly discrediting yourself with regard
That's
to
an assertion that you haven't substantiated.
Okay.
Yes, but that's all you make. You make assertions. The Michelson-Morley experiment did this. The Ally experiment did this. Blah, blah, blah did that. Blah,
And then
blah,
I
blah
look at the
did that.
first order
Blah, blah, blah
measurements,
did
and then I
that.
try to tell you how we've actually
And
derived first order
I am
measurements, and you
still
interrupt me when I try to do
talking.
that. and then
I'm
you-
still
and
in
then
the
you
middle of
rage
talking,
about it.
and
I'm
I
sorry,
don't
guys,
intend to
but-
stop just because you started.
But both of you have kind of pulled away from what we were just talking between Darryl and Allan. We've gotten back
Yes.
into the meta
So,
debate.
yeah,
So
let me take it for a moment, Tony. And I don't think y'all have this article, so let me share it real fast. Give me a moment. I shall share my screen momentarily after I position it
we'll give
in
you a
a
minute.
good spot.
Yeah, everybody got a minute on the floor and they shared their screen, so we'll give you the floor here, Darryl.
right. So you all, so let me know. Are y'all able to see it?
We're ready.
Is it showing? Nope. I think I
Like
got the
your
wrong screen.
screensaver.
on.
Yeah,
Oh,
we could see it. It was just your desktop
Try
screen
again.
there.
yeah, I was to say there was nothing there
Sure.
yet. That's right. It was sharing on my end. I did what I was supposed to do.
All right. What about now?
Test of
Yep.
the one-way speed of light. You're up and running.
Awesome. So both of y'all say this is a first order experiment. If you look at this, this is by the same three who wrote the paper, the other one that y'all wrote, Wang,
Yeah,
Jing,
he,
and
and he
Yao.
derives the first
It's-
order. Yeah, he
it-
derives
it-
the math.
All right,
it-
this
it-
is his minute.
I'm talking at the
Okay.
moment. It says, let me scroll down a bit. I'm gonna highlight where I'm looking at. To fully verify the principle of relativity required, we conducted a Michelson-Morley experiment. At least the frame of reference moving relative to the Earth, with which the principle of constancy of the speed of light will also be examined. The Michelson experiment is a second order experiment. The possible effect is proportional to V over C squared, where V is the speed of the system. And this paper also tells you why it's a second order experiment. Let me scroll it down a bit farther to page 2, and I'll highlight this for you.
Yeah, and actually, if you want to
It
know,
says,
what
one
I'm
second.
curious.
He's
One-
still
one-
got
one
his
moment.
30
Sorry, I'll
seconds.
wait till he's
We're looking
done.
at the
I'm sorry.
source
I
that
really
y'all
like this
brought up.
paper. I
Wayne,
apologize.
one moment, please. One moment, please.
All right,
Let him
so
As a matter of
reset your
fact,
timer.
as a matter of fact, I'm reading right here. The first, we have sine side 2, the first order term, but one is positive and another is negative, so they cancel each other out. Therefore, the Michelson-Morley experiment with the conventional mirror is a second order experiment. So the experiment, what happens is when the phase is altered by the reflection, the first reflection cancels out. That's why it's not a first order experiment. Y'all called it a first order experiment, and the data is not even there. The first order cancels.
I'll tell you.
So
I'll tell you
excuse
why
me.
I
Can
call
I
it
say
first
something real
order.
quick, Allan?
So excuse me.
Let's
Yeah,
let him
go
wrap up
ahead.
his thought. He's got
So
5
so when
seconds.
you all excuse me. So when you all say you don't have to understand first order, second order, third order.
It's not
When you all
what I
say you don't
said.
have to understand the
floor.
Taylor expansion, but you understand the experiment, obviously you're wrong. Because you're talking about first order when first order isn't even there. It's been canceled out by the sheer fact of the phases being
Buddy.
offset at a 90
That's
degree
time.
angle to each other.
Yeah.
Yeah,
So
can
what
I
you're
respond
saying
now?
is
He's just-
wrong. I showed
Go
that
ahead.
you have no idea what you're talking about. I showed
Go
that
ahead.
you don't even understand the fundamental math to understand the equations
Wrap
that
it
you're
up, please.
opining about. So everything you said about this is gone. I'm done. So if you want to
Thank
jump in, Tony, we're good.
Yeah. So that paper was published before Wang did the experiments where he linearized the Sagnac effect.
No, it's after.
Is it? Because he
Yes.
calls it a second order
Thank you.
experiment, but I'm calling it first order because if you take the reflections, right, and stretch it out, it's the same as a fiber optic gyro. It's the exact same. So even though he's calling it second order, it's not. He linearized the Sagnac effect.
And that's what he shows in
What
the
experiments
paper.
have you done?
He,
Huh?
What
Hey,
experiments
Darryl,
have you done
literally-
to confirm
Can
that
I-
the
can
first
I get
order
in?
stays?
Please.
I
Can
got
get
this,
in?
Tony. What experiments have you done, Allan, to confirm that the first order stays and Wang is wrong?
Ru-Yang Wang did them in 2004 and in 2003.
So how are you right and he's wrong when you're basing it off his work? I just read it.
Can
We
I
saw it.
can I please
He
now
said it's
actually
a
respond because
first
he's
order.
just not letting me
Excuse me, a
respond
second
because
order
I
because the
actually
first
have a
order
response to what he's
disappeared.
saying.
We'll let you
How
do
do you
Toby.
know he's wrong when he did the experiment?
I'm going to
Please
respond instead of
explain
Allan.
this.
Okay, Darryl, you got that?
Yeah, it's cool, Dave. Toby, if you want to jump in here.
Darryl, so first of all, just in case, like FYI, we've read Wang's papers live on air. Like we have multi-hour sessions reading these on the air. And actually, I just did a presentation on all 12 of Wang's papers about a week and a half ago, and I explicitly went through this paper. And the whole point of this paper is for him to corroborate what he did in 2004 and showed that his assumptions about the first order measurement of the one-way speed of light were actually correct. and he used the phase conjugate mirror to reflect the wave beam back the same. The front of the wave beam remains the same when you use a phase conjugate mirror. So you use a classic interferometer mirror, and then you compare that against the split wave beam going up against the phase conjugate mirror. And then when those come back and recombine, your phase difference then allows you to extrapolate out what the one-way direction of that one beam was. And what do you know? It actually corroborated his 2004 experiments.
10 seconds.
So
So to make
regardless
sure I
of first
understand
or
it
second
properly-
order, the speed of light's still not constant, and Einstein's still utterly wrong. And you're living in a fantasy land if you think that the speed of light is constant.
That's time.
Let me sure I'm understanding you properly. Michelson and Morley used the phase conjugator to get a second to get the first order.
No, you're lost. We're talking about Ruyang Wang,
I'm
2004,
asking,
2006.
Did they use the phase conjugate mirror, Michelson and Morley?
So you're trying to get us on a gotcha first versus second order measurements. That's not going to make the Earth a globe, dude.
I'm asking you a question. I'm asking you a question. Did Michelson and Morley use a phase conjugate mirror to get the first order result?
No, and no one said that.
Then it's not a first order experiment. You're wrong.
So
You're contradicting what Wang
Well,
said. You're
Just one
wrong.
second.
We just read it. So it doesn't matter how long you read the
Hey,
papers and how
Darryl.
long you
Audience cares
opine
about
about
This
it.
time.
You're
Darryl.
still wrong.
Daryl, I got
Go-
you, Brody.
go ahead,
I might
Tony.
I might be wrong about my interpretation of that with the Michelson Morley.
Can I ask a question?
If it's a second order, does that change the velocity that was measured though? Right? Because your whole thing that you kind of linchpinned or that you kind of hung your hat on was that they were measuring the relative velocity of the entire solar system and the motion of the Earth, right? They still didn't get a proportional velocity in their second order measurement, right?
It's because the
So-
ether is not real. That's why.
That's
No.
your
That's
assertion.
That's why it's a
The-
no
the-
result and it led to relativity.
All right,
It-
Tony had a
it-
question
One
there, guys.
second, one second,
All right,
Brady.
last 30 seconds.
If the ether is stationary in their proposition, right? Then what they're measuring is the velocity component of the. You can answer if you want.
Is
Of
that a
the Earth.
question?
Of the
Darryl,
Earth.
did you understand? He's asking you a question.
No, I'm
No,
sorry.
I'm-
I thought you were talking to Tony for some reason. What did you say?
Oh, it was just for anyone.
Okay.
So
Okay.
if the ether is stationary in their proposition, right? They're saying this is a stationary ether and the Earth is moving, right? So if they take a measurement, if there's a fringe shift pattern displacement, if there's a proportional velocity measured, is that the ether moving or the Earth? What is it?
I'm going to defer to the experts. They found that proves that there's an ether.
Do you have any, can either of you produce any observational evidence telling me that showing me that ether exists? Any scientific observation that tells me peer-reviewed, published, that there is such a thing as ether?
2004, Ruyang Wang. Sure, there you go.
Um,
1913, Georgia Staniak.
1913, Fresnel measuring the translational speed of ether drag.
So
through
you're
water.
claiming that the
King Miller,
existence of the
1925.
ether is an established scientific fact.
100%.
I mean, it's not accepted within the
Okay,
mainstream because the mainstream paradigm is
lying.
relativity. Oh, cool. You got us. Do you think we don't know that the relativity is the mainstream theory that, utterly that has to throw out the idea of a substantive medium necessary for electromagnetic waves propagation?
But you have no observational evidence that this is true.
All
Certainly,
interferometry ever.
So you're just discounting everything we said, all the evidence that we actually
interferometry
brought.
ever does not. Can you all interferometry ever does not cut it.
What's the velocity relative to?
Let's let Tony finish his thought.
Let's look at this. We have gravitational time dilation observed at Earth's surface, right?
No.
You a pound Repka? Is that what you're going to say?
How would you like to substantiate that? What experiment would you like to cite,
I
sir?
think he's going to go with pound Repka.
Yes.
Wanna hit
There's
a pound Repka?
no,
Please. Pound
Oh,
Snyder?
okay.
No?
nope,
What, atomic clock?
yes.
Ooh, here we go.
Please.
Well, so this is a published result of gravitational time dilation. Why do you refute it? Why do you reject it?
Well, let's hear the details.
Yeah, give us the deets, brother.
So this is Bothwell et al. I can allow me to share my screen.
Sure thing. Thanks for letting me know.
What's the name of the source so I can also pull it up on my end?
It's Bothwell et al. Nature, 2022, resolving the gravitational redshift across a millimeter scale atomic sample.
All right.
Okay,
While
continue.
you get that up, so yeah, we have been going for an hour and a half. What would you guys say? How much longer would you like to have your open discussion before we move into
I'm
interacting with
fine
our
with
audience?
questions. Yeah,
I'm
I'm fine
fine
with
with
questions now.
questions. This exchange
I
is
did what I
pointless.
wanted to do, so.
So here
Okay.
we have supercooled optical clocks that are separated by less than a millimeter, and show a difference in their interference patterns between electron transitions. So here we have peer-reviewed observational evidence of a difference in time characteristics for atoms at different gravitational potentials. Do you accept that that is what this paper describes? Do you assert that you are better able to review this result and critique it than the people who were asked to do it for the Journal of Nature?
Is that relevant to this debate?
Yes, it is.
One
It's
second.
not.
Because you're about to assert that this is nonsense, and you've got nothing other than your say so, and you,
hold on.
I repeat, have no qualifications to bring to
James,
this
is he allowed to just
discussion.
sit there and say what we're about to do before we've even like had a chance to say anything? That's just like, it's really edifying.
Well,
for the
go
audience
ahead
or
and
for, like, is that
don't
debate?
refute it and concede that gravitational
I don't
time
want to.
dilation.
I don't want to interrupt you.
You will get.
I'm,
I was gonna
I'm
say.
trying to. I'm trying to respond.
Yeah,
So,
no. If you ask for time to respond, I'll always give you time. So if you want a minute, I'll give it to you.
yeah. So what do we got going on here? Again, we have an atomic clock. You said.
Yes, we've got atoms of supercooled strontium. We're looking at transitions between their electron shells and the populations involved, and we're using that as a measure of time. And we can show that that if we move if we start out with them at the same gravitational potential and then move one up, we get a difference in the transition
Gotcha.
between the electron populations.
Gotcha. So it retards a little differently.
Yes.
Okay. So my explanation for this, because I came across this in GPS with atomic clocks and whatnot, right? So they have what they call the general relativity correction, and they file that under the equal gravitational potential at altitude, right? So they say that the satellites are orbiting at like forget the altitude, but it's like a fixed altitude. So they say that the gravitational potential there is equal, so they have it synchronized to the same amount of retardation. Now, what I think the retardation is, right? Because you guys think that's a gravitational time dilation relation, right? I think that it's as you increase in altitude, right, the electric gradient gets stronger, and that causes more retardation within the clock. Now, this is important because these measurements are so minuscule and small. Like this is where this is going to affect that. So that's my interpretation of what they're calling gravitational time dilation, right? It's just
So that's exactly what I thought.
altitude.
That's exactly what I predicted you would do, which is that you would make up something
Have an
with
actual
zero
mechanism to explain
qualifications
it.
and zero observational evidence, and just throw the paper out.
Well,
That's exactly what I said was going to happen, and you gave me a hard time. And your mate there gave me a hard time for you're saying we're going to do all these things, and then you went and did exactly what I said.
Wow, what an assertion!
I did not. I'm not throwing out the paper, right? I'm giving you my mechanical explanation for the retardation, right?
You are giving me a word salad with no observational validation, and this is the point that you keep on missing. You need observational validation. If you're going to assert that this is the case, my guess is that actually this experiment would have taken place inside a Faraday cage, which is to say that the mechanical apparatus would have been made of metal that was designed to shield it from electromagnetic effects. So you're going to have to tell me how this minuscule change in potential is going to have a perceptible effect, and you're going to have to demonstrate it. You're going to have to do it in different gravitational potential gradients and show me the same thing.
Last minute
and you
before
haven't
Q&A.
done that.
Did you say that this was done in a Faraday cage, or you think it was?
I think it was done in a gravity cage. If you look at you look here at the cavity, it's made of silicon. Maybe that isn't a Faraday cage.
Well, in any case, fuck, Fuck, I forgot what I was going to say now.
Well, we got 30 seconds. So, Darryl, Toby, do you have any other thoughts before we go
I'll
into
just throw
Q&A?
in real quick, like
Oh, yeah,
honestly, Tony, I every time I go looking for evidence of special or general relativity, I got led to GPS. Then I found out that that was actually proof of the Sagnac effect and classical mechanics as opposed to special. So I got literally a debunk of special relativity. I got led to Pound-Rebka, which doesn't align with or with general relativity. I got led to, like, every time I get led to anything, it ends up, or I got led to Thomas precession, which
That's
invokes
five.
a double Lorentz boost or Lorentz rotation,
Or you
every
don't
time
understand
that-
scientific papers.
You're just interrupting me.
One
to
of these
gaslight
things
me.
is true.
Don't interrupt me.
One
to
of
gaslight.
these
At least say
things is
something
true.
One
substantive to
second there,
say.
Tony. I
Good
want,
grief, man.
I want
So
for
anyway,
the sake of our
well,
discussion
can I
there.
finish my thought? I'm like literally trying to explain what my response here.
All right, if you can do it with 10 seconds, because I want to give the
I
last
can.
word to Darryl.
I'm almost done. So the Thomas precession, the last thing that the place I was told to go look for evidence of relativity, it invokes a Lorentz transform, which can't even be substantiated unless you can somehow magically pop out of the lab frame, which is reality, to substantiate it in the non-reality where it actually did the Lorentz rotation or the double Lorentz boost. So every time that I actually go and investigate it, it ends up being a disproof. So I will look into this, but just looking at it from what I see so far, I'm not super convinced, but I'll see when I look into it.
All right, Darryl, anything you want to say before we jump to Q&A?
Yes, it was a pleasure to be here. It was great being on the board with Tony, and I just wanted to reiterate the point that I wanted to show, which is what Tony showed again. Time and time again, I see these globe deniers, whether they call themselves flat earthers or concave earthers, or I'm just a globe skeptic or whatever.
10
Apparently,
seconds.
there's this fad where they present scientific papers where they clearly have no idea what they're talking about. They have no idea of even the basic mathematical understanding necessary to even
That's
realize that they're making conclusions that's contrary to what the paper itself is saying. If you understand Taylor expansion, you can look at the two papers and see why Michelson goes up to such a high Taylor expansion.
We are
Oh,
at
am I
time.
muted?
No, you're not muted, but we
so-
are at time, so
Okay.
that's okay. I try not to be too right in the mics because I want everybody to be able to hear you. So if you didn't hear me say that,
Okay.
that's all fine. I'm going to close out our poll, everybody. So I had a poll that I opened up right at the beginning of the old debate, and we have our results in. So it was bouncing back and forth hardcore for a long time, and 1,000 of you guys voted in the live chat. So thanks for all the engagement in the poll. Why don't you hit the like button, all 1,000 of you that voted in that poll, since your thumbs are so active and you can do that. So 46% voted a globe, 40% said flat, and undecided, I will say, but I said a bag of bread. Old joke. A bag of bread was 12%. So we'll just say they're undecided, and we're going to keep figuring it out. 12% as we go through our super chats. So once again, big thank you to the moderators in the live chat. Thank you guys for keeping it civil and making sure that everybody in the live chat knows that we want to attack the ideas, not the person. LJ coming in for $1.99 says, so NASA is the only government that doesn't lie. 1 minute there, Anthony and Darryl. We'll try to move through.
Yes, flat earthers lie. So we should stop listening to flat earthers. Everybody lies about something. The existence of liars does not make everything false. If you can show me where NASA actually were deceptive in what they did, fine. But that doesn't change the rest of the mountains and centuries of evidence we have relating to the shape of the Earth.
Did you want to say anything to
I
LJ?
dovetail off that as well.
Yeah, sure.
So going back to the discussion we had just now, I brought up that paper, and Allan said, "Oh, that came before what we just did," and then Toby was like, "No, it did come after." So where did Allan even get that from? So
It was a
both of
mistake.
them said something different.
It was a
Is
mistake.
one? What did
I've
you
read
so
a
where did
lot
you
Years
get that
apart from
Allan?
each other.
I thought that paper was before Wang, because actually when you were pulling it up, or like I was anxiously awaiting, because I thought that it was beforehand, because I've already read
So
that.
that means that we shouldn't listen to.
No, I was
Go ahead, I'm
already
sorry.
aware. I was already aware of his of how it's a second order, right? But I had my own interpretation of it, and that might have been wrong. And I'm glad that
He's
you
done.
pointed that out, bro. Like it's all good. Like it's not a big deal.
I think it is a big deal, because
Well, there's a
I
third- he-
only found that I was
hold on,
debating y'all. I
well,
only
hold on
found that
one
I was
second.
debating y'all yesterday. I
Mhm.
looked over the course of that paper in a matter of, like, because I still have to do homework for my classes and stuff. Probably spent a total of 2 hours, and I understand it enough to point out how wrong you all were. When you all talk about all these hours y'all spent talking about it,
well-
that's a big deal. I think that's a
Hey,
very
can I
big
can
deal.
I interject
And it
real
goes
quick,
back to
Yeah,
what
Alan?
Tony
okay,
was saying.
We're putting it over to
Darryl,
Toby.
he's not
These
answering the
papers are-
question. He's just like attacking Alan. Can I interject something about this? Because I have something really relevant.
Go ahead,
Alan
Toby.
actually did a presentation. Alan did a 3-hour or a 2-hour presentation called On the Orders of Measurement, where he went very into detail about first versus second order measurements and his opinion
Still
about
doesn't
this.
know
So
what
to
a
try and
Taylor
talk like he
transform is.
doesn't know
So-
what he's talking about is absurd.
All right, so this is their
Listen,
question.
don't
So
know
we're
what a
looking-
Taylor
I'd like
So
to
he-
probe that. So you're saying that he talked about it for a long time, therefore he must know what he's talking about.
Exactly.
No,
He
I'm
That's
talked about
saying
it
that
for a
you're
long
trying
that's
to
your
act
time.
like you got it
syllogism.
with a
Everything.
gotcha, but it's like he literally did a
No.
presentation called On the Orders of Measurement. So to try and pretend like he can't have
While
his
he
own
still
opinion
doesn't know
about what a
Taylor
first
expansion
versus
is.
why that's a
Um,
first order measurement or not. It's it's a weird gotcha anyways, right? Like it doesn't make the earth any more globular for you. It doesn't make
Yeah,
the
but
ground
it-
beneath your feet moving any faster for you.
But what it does show is that you don't have a grasp of logic. You keep on making these claims. He
All right,
talked for
you
for
gotta shut
3
the fuck
hours.
up
Two
for a
different
second.
papers, one
He
2004,
talked for
one
3 hours
2006. They
about
showed
this.
two different things. Who
Look,
cares
hold
if he has the
Just 1 second there, Toby. This is their question. So we're going to let
Okay.
Tony close it out here, and then we'll move on.
All right, I'm going to close it out. I showed a mariner's textbook from 1679 that shows that they were using spheroidal geometry to successfully navigate back then. What the hell has NASA got to do with the Earth being spheroidal? Nothing.
who said
All
that?
Well, let's move on to the next question there, guys. And we'll try to, like I said, keep it to, like I said, if it's asked for a specific side, then, naturally the floor is more in their direction. So if questions are coming in for Toby or Allan, the floor is going to be more yours. It's just the way that this goes. So I am sorry, but I think I've been pretty fair. I think everybody's been muted at least once except for Darryl because Darryl's just love you, brother. You're just great. Witsit Gets It says, Tony, does your model not claim motion? You're ducking.
No, what I'm suggesting is that the evidence related to the shape of an object is different from the evidence related to the motion of a subject. We could go into geostrophic flow and how that is absolutely impossible on a flat Earth. We could go into western boundary current intensification. We could go into Doppler shifts of the wavelengths of incoming stars at different points at different times of the year. We could go into the abundant mountains of evidence we have for the motion of the Earth. But the reality is that the geometry of an object that we can measure, you want to talk about Michelson and Morley, but we can measure distances on Earth. We can measure the changes in longitude. And if you're going to ignore the fact that a given band of longitude does not increase in as you go further south, then all of a sudden you're going to require thousands of degrees of longitude rather than the 360 that are known to exist.
Any thoughts, Darryl, before we move on? For Witsit?
You got it.
Okay. Thank you so much for your question there, Witsit. And we always appreciate having you
He
on here.
conceded geocentrism. Cool.
Oh my. Let's these guys have been a pretty active bunch, right? So yeah, once again, if you haven't hit the like button, what are you doing? And just sitting there with your thumbs up your Witsit Gets It asks, hosting debate after show on Witsit Gets It. So for anybody who wants to head over there, Witsit's putting that and making it known in our live chat. And once again, we appreciate everything you do, brother. So hanging out at Modern Day Debate, doing all the debates. It's a lot of fun. So cheers. November says, how'd ships navigate hundreds of years prior to the globe?
Well, they did it by, they had a variety of techniques. There was a lot of coast hugging. The Vikings, for instance, used basically angles to the sun to navigate most of that. But the Vikings have been overestimated. A lot of their discoveries, for instance, the discovery of Greenland, was by accident. They were blown off course. They discovered Greenland. Traveling to Greenland, they got blown off course. They discovered Canada. They didn't have spherical geometry, but they weren't traveling far enough. They weren't making transoceanic voyages at that point.
Any other thoughts there, Darryl, before we move on? All right. Let's see. We've had a lot of questions from you, Witsit, here. So let's get to another one here for the other side. Mark, everyone type motion so globers can address it.
What did he say?
Said everyone type motion so the globers can address it.
Everyone type motion so the globers can address it. I guess he wants us to talk about how we know there's motion.
He's trying to do a call out in the live chat. Yeah. So if you guys want to take a
Okay.
minute, I was
Okay.
trying to find one for everybody, or at least Toby and Allan, but we'll give you guys a minute here, and then I'll find one for you guys.
Well, I think that directly relates to the things I showed. Like I showed images of the planets, but how people get those images is that we've plotted where these planets are. So for instance, you can use Kepler's laws, and we know how long these planets take to revolve. So looking at the planets, seeing where they are, seeing them going around us, modeled off a globe, that lets me know that we're moving. You know.
Any thoughts, Tony, for the last 40 seconds?
Yeah, essentially, if you've got a high pressure air system or water system and a low pressure water system, the air should flow directly from one to the other, but that's not what you see. What you see instead is that you get wind flowing roughly parallel to the isobars rather than across them. This is caused by what's called geostrophic flow. Earth's rotating. The flat earthers will claim some magical ethereal effect that causes this on gross matter. They've got no justification for claiming that, no observational experiments, but it accords exactly with the predictions of Coriolis.
All right.
It also brings up neutrinos, talking about the Earth, because we have neutrino detectors that can detect neutrinos from the sun as we rotate around, different sides of the Earth. So, I mean, there's many ways that we know that the Earth is moving. So
let's let Toby interact here, because we don't have as many questions for Toby and Allan. So go ahead, Toby.
Yeah, how do you know the neutrino came from the sun when they say that cosmic rays come from literally every possible source in the sky?
I'm going to investigate in detail. I did ask my professor that, but she basically told me it was basically the process that the calculator understand is going on in the middle of the sun. I don't know the details.
Yeah, you know they use neutrino detection for random number generation. They use neutrino generation for random number generation. They've never been able to properly model it.
So so if I point a neutrino detector at the sun while the sun is above the horizon, and I get a certain signal from it, and then I continue pointing it at the track that the sun should be following as it passes below the horizon, and I continue to get neutrino detections from it, why are you asserting that the sun is not being tracked by the neutrino detector? At what point does the neutrino source pass underground while the sun doesn't?
In your thought experiment, if we were to do that together,
it's not a thought experiment, it's an observation, sir.
Okay, which one?
It's
not a neutrino detection of the sun.
Which observation are you? Give me a reference, please.
I could clarify for him, Tony. This is what Tony's saying. He's saying if you point a detector at the sun, and you
I understood, and I was trying to actually entertain that thought, but he interrupted me when I tried to.
And I'm sorry that I interrupted you, Toby, but we're in 3 interruptions here. So sorry, Darryl. Finish your thought there, if you don't mind.
Yes. So what he's trying to say is, when you point the detector at the sun and keep it pointed at the sun, you can follow it. So I thought you was asking me, like, how do you know neutrinos are coming from the sun? Like, what's the process? But that's what you're talking about. You just keep it pointed at the sun and you follow the sun. Like, there's not a point where there's a disconnect where suddenly it breaks off and then it could be from something else. That's
your
what he's saying.
assertion that the neutrinos are definitely coming from the sun is where I'm saying there's a problem, right? Like maybe if you point it at the sun, maybe you get more neutrinos, sure. But based on the randomness of neutrino detection, I'm telling you, you have no way to differentiate between whether or not it's coming from the sun or not, based on what I understand about neutrinos. Maybe I'm wrong about that, but
you are making a baseless assertion.
Let us show the calculations, Tony. There's a whiteboard here. Show us those calculations of the randomness that where you can't.
I can pull. Can I? Oh yeah, if I can share my screen, I've got a bunch of papers on that.
No, show us the calculation because I already
No,
showed that you
it's
all
not
don't
a simple
understand the papers you
calculation. They
read.
actually use
Show me the
supercomputer models.
calculations themselves.
Well,
Don't bring in
I would have to
paper.
get into the source code of their neural networks, right?
No,
Because they
so
actually
you
use
don't
computer.
understand the calculations. So
No,
you
I can
can't
show you
say
the
that.
papers and all my highlights right now.
You don't
All right,
understand
we can share
papers. I showed that
screen.
earlier.
Let's do
You don't
3
have the
minutes.
understanding to understand these papers you're
More
putting up.
gaslighting. You know, that's
Well-
literally all you've brought to this conversation is a bunch of gaslighting.
All right, without getting into the meta,
No.
because we don't want to go into meta debate. If you got something you want to share, we'll give you guys 3 minutes to wrap up thoughts on this one. You lucky super chatter, you're getting so much more out of your question than the first couple here. But yeah, just because we had only a few here so far for Toby and Allan. So if you want to do a screen share, we'll give you 3 minutes to have some fun with this one, guys.
Oh wait, I'm in the wrong folder. My bad. I shared early.
Oh no,
Here we go.
never want to share early.
So let's see. We've got overview of the Earth's picture. Good. Shoot. Shoot, I must have them in their own folder somewhere.
Okay, if you want to take a minute to find that.
Sure. Yeah, let me find it and then I'll pull the paper up. My bad.
Yeah, we'll return to that. Let's ask the next question here, and then we'll let you pull us back here in just a second. So thanks once again for everybody who has asked a question. We'll continue on with the super chats while Toby gets it up. And once we're finished with the next super chat, Toby, just pull us back full circle if you don't mind, buddy. So LJ coming in says, why doesn't the Earth spin under a hovering helicopter?
Well, it doesn't spin relative to the atmosphere under a hovering helicopter. So the atmosphere is rotating roughly in phase with Earth's surface. So you don't expect any motion between the helicopter and Earth's surface because the atmosphere is rotating at approximately the same rate.
All right. Are you ready over there, Toby, with your screen?
Sure. Yeah.
Okay.
That.
We will go back to what we were just discussing, and thank you so much, Tony, for answering the question.
So yeah, here's one paper.
There.
So ionization of the Earth's atmosphere by solar and galactic cosmic rays, and they're talking about how they use new methodology, calibrated direct observations, but they use a numerical models, and then ionization of the atmosphere comparison between measurements and simulations. Some discrepancies are found between actual measurements. What do you know?
What's this got to do with solar neutrinos?
Showing that they compute the whole thing, and it's every time
These are
that they try
cosmic
to
ray calculations.
What's that?
I was thinking as well.
These are cosmic ray calculations. They're
Yeah, that's what
not
I'm showing.
solar neutrino observations.
Cosmic,
was
so
thinking as well.
neutrinos, you're trying to tell me neutrinos not related to a cosmic ray?
Yes. The vast majority of cosmic rays are extremely energetic particles, not neutrinos. As for
I'm
instance,
pretty sure you're wrong about that. But I don't want to waste our
then
time
you're
if
an
I'm
idiot.
wrong.
So the spallation, the carbon 14, for instance.
My real
carbon
point
14,
was that they use them for random number
Okay.
generation.
Carbon 14 is created by spallation of oxygen and nitrogen in the atmosphere by incoming cosmic rays. Neutrinos don't do that. In fact, there's an array of cosmogenic isotopes that are produced by cosmic ray impacts where neutrinos pass through matter. Can you see the distinction between the two?
Well, hello?
And this goes back to what I was saying. I wasn't trying to gaslight y'all. I was pointing out the fact that y'all don't understand these papers that you're reading. So, I mean, there's no good to bring them up anymore. And that goes with every single flat earth that I've seen so far. None of them understand the papers they bring up or the math behind them.
What did I not understand? You're saying that I had a misunderstanding of neutrinos, which I still don't think you're necessarily right about. So like, is that the only thing that you're ranting on about right now is my potential misunderstanding of neutrinos?
That's the only thing that matters.
Neutrinos are not cosmic rays, mate.
What you're saying.
You're trying to talk about
rays.
neutrinos and you're showing us stuff about cosmic rays, and they're not the same thing.
Yeah, so I wasn't gaslighting you. I was just stating a fact. So You know, you just basically just proved my point for me. But you know, we could keep doing it.
All right. This might be a good time to move on. If you don't mind, I'm going to end this screen share. And let's ask the next question and keep interacting with the audience to keep the conversation rolling. And once again, thank you to everybody who has
Neutrinos are
contributed.
expected at some level in association with cosmic rays. What do you know? Huh.
Yes,
right.
some cosmic rays are neutrinos. The vast majority, however, are not. That's like saying that all people are male. It's just not true, or all people are children, because the subset this is another logical fallacy. You are trying to relate solar neutrinos, the observations of solar neutrinos, to cosmic rays,
They're
and you're
all
looking at
random.
the properties of cosmic rays, which include stuff other than neutrinos.
They can't properly simulate any of them. They're all random. They're all literally, like, you could literally use any of them for a random number generator.
So
Last
what?
word. Okay.
I got nothing else to say.
Let's carry on there, guys, because we're a little over time on that question. And when I'm doing housekeeping, don't interrupt me. My goodness, you'll throw off my groove. You don't want to throw off the Emperor's groove. I'm just making a reference for all the 90s children. All right. Unconditional Truth says, can Toby and or Allan explain how GPS falsifies relativity and therefore heliocentrism in general? Doesn't the current globe model require relativity? We'll give you guys a minute and 30 there each, or not each, sorry,
So,
a minute and 30.
Yeah, atomic clock synchronization, the way that it actually works, falsifies special relativity, because the way that the atomic clocks are situated in free fall around the Earth, they shouldn't be retarding proportional to their own velocity. So not even not counting keeping the clock in sync with other clocks, just maintaining the oscillation rate of the atomic clock itself. It has to account for its own velocity, which they say, it's in a free fall orbit, therefore it's a local inertial frame. So, the speed of light should be the same. It shouldn't, especially the one-way speed, it shouldn't change. So its own velocity should not cause any retardation in the oscillation rate so that it can keep time. Now, what's interesting about that is that, okay, so it's free falling around Earth. It's got a proportional velocity correction that it has to make for its own velocity, right? But as it's free falling around the Earth, it would be parallel and
5
perpendicular to the planes of motion. Like, so the orbit of the Earth around the sun with respect to the center of the galaxy moving with respect to the cosmic microwave background, all these velocity components never show up in any of the clock corrections. So if the atomic clocks and GPS are proof of anything, it's that the Earth is geocentric.
Okay, you got 30 seconds left there, Toby.
Can he provide a single scientific reference for what he just said?
Yeah, Paul Marmé and all atomic clock synchronization standards.
This is their question, Tony.
Bring it up.
So the
Live right now? Okay.
The last 38 seconds. Okay. We'll go.
Jesus Christ, dude.
We'll go down there. But last 38 seconds to you, Toby, before we bring that up. Apparently we're coming full circle. So go ahead.
Yeah, so the whole thing goes back to, measuring the motion of the Earth, right? We tried to measure the motion of the Earth using using interferometry, which is the quote unquote speed of light or electromagnetic propagation. And then when we didn't measure any motion, they said, oh, well, that's because of relativity. The apparatus shrunk in relation to the sun and you couldn't actually measure it. Well, and they say that the speed of light is constant. So that's why you could never even measure a proportional velocity using the speed of light. But it turns out when you look under the hood of GPS and range measurement equations, that whole equation accounts for proportional velocity in it. So the equation itself violates and, basically debunks special relativity. We've known about this since the 90s with Ron Hatch. Yeah.
All right. Let's go down the rabbit hole, fellas.
All right. So we'll start off here with.
Is this a paper? Are
Yes,
you showing me a scientific paper?
Yes, these are clips of papers that I put into
These
a
are clips
presentation.
that show me the paper.
You want Jesus Christ, dude. You want the exact ones, each one?
Yes, I want the exact paper.
Listen, okay, dude. Here's what we're going to do. I'm going to show you.
And also, I want you to
Listen,
show
guy.
me where
All right, hold
in
on a
that
second.
paper it
Listen.
says this disproves special relativity. Because what you're doing is you're cherry picking stuff out of papers and you're saying this means that special relativity isn't true.
Ryan, can you mute him
let's-
so I can get to
That's
this?
not how science works.
All right, we will let you respond there, Alan, and let's try to keep the
All right.
discourse up
So-
here, not
So this
down
is
here,
how we're
guys.
going to do this so we can move through this quickly. Now, I'll give you all the citations so you could look them up on your own time. But for the audience's sake, what we're going to do is we're going to look through clips of these. If you want to call it cherry picking and all that, that's cool. Totally fine with it. You can go back and read it on your own time. So this is a paper from 2005, the interpretation of special relativity applied to the local central inertial frame, blah, 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 right? So what he's going through here is he's talking about how there's these different planes of motions that would show up in the atomic clock corrections if they existed, right? So what we have here are some diagrams that he puts forward. So as the satellites are orbiting around the Earth, they're going to be parallel and perpendicular to these planes of motion. So that would require, if you follow Galilean velocity addition, this is what this guy's saying, like, oh, you're just making shit up. This is what he's saying, that these velocity corrections would have to be applied to the atomic clock for it to keep time, but they don't exist. They've never been measured in interference.
Hold on.
That's
He's got
spurious
10
nonsense.
seconds. He's got 10 seconds
Please,
left.
before you shit the bed, bro, just give me 1 second.
You got 10 seconds.
All right. So here we have more GPS references. This is other people noticing in their careers that, hey, how come none of these atomic clocks have to account for this 30-kilometer velocity or anything like that? Okay. Now, if you want all these references, I will gladly give them to you. Okay.
Okay.
There's
You aren't
there's
screen
more.
sharing.
We're,
I get to
we're
respond
trying
now?
to move on.
For sure, but you're not screen sharing
Unfortunately.
right now, Alan, if you have meant to be.
Okay.
Oh, for fuck's sake. No. My bad.
So-
I thought I was screen sharing the whole time. My bad.
Oh,
So
you said,
just to
look here.
respond to that, those velocities should only show up in the clock correction if Earth is not sharing them, or they're not sharing those motions with one another. If the entire system is moving with that velocity, there's no way that that they can detect that velocity. That would be a violation of the very fundamentals of relativity. You can't detect your velocity just by looking inside the system. And as for Galilean addition of reference frames, that's not how relativity works either. So you're claiming to falsify relativity by completely ignoring what relativity is. Again, this gets back to, you need to be qualified to read and understand a scientific paper. If you aren't, you're going to take stuff that's mentioned in a paper and you're going to be wrong about it. And it baffles me that you don't
5
accept
seconds.
that this is the case.
Next time I do a debate, I'm going to put a little gaslighting counter like right here. I'm just going to ding it every time we get gaslit.
All right, let's
And
move on
that
to the next.
assumes that this again assumes this is all based on an assertion. The assertion is not only are these guys qualified to comment on scientific papers, they're qualified to comment on whether or not somebody else citing papers is gaslighting.
Okay.
They have asserted themselves
5
as
seconds.
arbiters of science. It's unfounded.
Okay, the question was for you guys, so you want to close this out there, Alan? We'll carry on.
I don't even remember what the question was.
It's about
What was it?
GPS, right? We're still on GPS.
Yes, we were talking about can both Alan and Toby give a few reasons? Yeah, go ahead.
Can I say one
Yeah.
more thing on GPS? Like Albert Einstein's clock synchronization, he invoked it in the 1905 on electrodynamics of moving bodies, and that he invokes clock synchronization as his only way to get away from absolute time. And then when they actually went to go start setting up GPS crafts later on down the road, all the clocks started going out of sync with each other. And it's like, holy cow, Einstein, what are we going to do? You told us all these reference frames were equal. And then they had to go back and sync all those clocks. They have to sync them all back to sidereal time. And they do that through the range measurement equations, which rely on proportional velocity and the speed of light. And if you take out that proportional velocity, you actually end up not being able to detect where people are. And if you take out the one-way velocity, the isotropic or anisotropic effect of light with the one-way preferred directionality, you're off by 30, 40 meters. So both of those things utterly violate Albert Einstein, 1905 special relativity, and everything after that. It's just a bunch of ad hoc nonsense.
Have you written any GPS code?
No, I've looked at the 1980 and 1990 documents for the IEEE, and I looked at the Paul Marmé paper where he actually goes through the math from the IEEE and shows the references from the IEEE, and also
We've
a couple
already
of,
established that you reading papers is irrelevant because you don't
you're
understand them
interrupting me to
properly.
gaslight me again. That's pretty cool.
The
I hate to get meta about
I
it, but
work
it's crazy
with
how many times
people.
you've done
I
that.
work with people who have written their own GPS.
If you're going to
code,
interrupt me,
mate.
have something substantive to say. Don't just
right.
gaslight me. It looks really bad.
Let's move on,
Ask a
guys.
question.
We can keep
May I ask a
going down.
question before we leave this topic?
Okay, we're
Ryan?
all right. If as long as you can pull us back in because we're
Very
spiraling right
quickly,
now.
it'll be a short one. Toby or Allan, when you're talking about these GPS and the satellites that do it, which one of these reference frames would be proper time?
I don't know.
All right,
That means you have no idea of special relativity. You don't know what you're talking about. We could keep going.
let's
You
go.
know, they
there.
have to do it on the back end at the reception time. They do it on the back end with when they do the range measurement equation, and everything goes through the global
That's
coordinate system. And there's actually like
No,
when
it
they
doesn't.
One
they
second,
actually even
Tony.
tried to do
Last 5
really quick,
seconds,
really
Toby.
relevant. They tried to do an analysis of global coordinate system result of GPS. And when the people that did the analysis, the datum that they got, the data set that they got had
That's time.
already been run through these corrections, and they were able to tell just looking at the data set that, hey, this is already corrected. We don't actually have raw GPS data. So every time that GPS gets invoked or used, it goes through that transform to the GC.
We have to move on.
I need to respond to that because actually, if you
We'll
do
be
if you
here
do
on this
your
one
own
question.
GPS, if you do, he's talking about commercial GPS systems that rely on the positions of the satellites that are transmitted by the satellites. This is
seconds.
not how the high precision GPS solutions actually treat the satellite positions as unknown, and they solve for the satellite positions and for the orbit perturbations that are going to fit. So they don't assume a terrestrial reference frame, and I don't know what he's talking about because
Citation, please,
I've
preferably
worked
an
with the
IEEE reference document.
I've worked with the people who do this. And
Preferably engineering standards.
there may be an individual study with a flaw
5 seconds, Tony.
that they have detected, but that's not how GPS
So you don't have a
is
citation, and
developed.
it's definitely not
All
going to be
right,
from
guys.
engineering standards.
We got
Gotcha.
to move on before we start dishing out the old mutesy poos because I don't like doing that. And we do have so many questions, and I want to be able to engage with these. The people that have been listening to you guys have this discussion. They've got a lot of thoughts, so keep them coming in, guys. If you got more thoughts as these guys keep discussing, but we are going to try to move it along because if not, we'll be here all night. So Free Palestine says the Greek knew Earth is flat and non-rotating. The Antikythera mechanism, aka the flat Earth model, it's a zodiac system. A globe model can't predict. All right, and
That's
1 minute for
that's
you guys.
nonsense from beginning to end. The Greeks developed spherical trigonometry. Menelaus's theorem was developed and written down. This was how they solved a number of problems. In particular, it was one of the ways they were able to calculate from the maximum length of day what latitude you were at. This is the calculation that flat earthers simply can't do. The Antikythera mechanism is not a flat earth mechanism. It's a simple cyclic machine. Actually, the flat earthers often claim Soros cycles can be used to predict eclipses. That's not entirely true. Every Soros series begins and then it carries on at Soros intervals, but then it stops. So you can only use the Soros cycles for a Soros series that has already started. You can't use it to predict when a new series will begin or when that series will end.
Okay. Any thoughts over there, Darryl, for the last 15 seconds
Right.
before we move on?
May I hear that question one more time, please?
The question was, the Greeks knew, I'll give you 30. The Greeks knew Earth is flat and non-rotating. The Antikythera mechanism, aka the flat Earth model, is a zodiac system. Globe model can't predict. I'll give you 30.
Yeah, I guess today I would just say I spoke to a flat earther that talked about the Antikythera mechanism, and I asked him to demonstrate it, and he do one of the deceptive things flat earthers do, which just change the subject and run from it. So why don't they demonstrate it? Like Tony is saying, show some evidence for this stuff.
Sorry if I'm making a face. I was just trying to verify if I hear children laughing in the background or if that's crying. I'm like, is my kid crying right now? No, he's fine. They're laughing, even though they're not supposed to be up because it's 11 o'clock in Nova Scotia. So I think we're gonna have to kick their butts after this. After we close out, they're supposed to be sleeping. What's it gets? It says, "Why do you think you just get to scream over them?" Well, what's it? I don't think I've been that loud. I haven't been screaming over anybody. But if you want to hear me scream, you know what? I did a demo earlier today, and I got the file. I'm gonna put it into my OBS right quick. You want to hear me scream? Here you go. We wrote a song about hubris. And it's called Greed. So I'm just going to pop into my OBS, and you can hear the demo that I recorded today. You want to hear somebody screaming. All right, Earth is Life asks, Toby, so when flat earthers make videos claiming they see too far, like Canagoo, laser tests, etc., what do they use to measure the distance?
These optics, and they zoom in, and that's, it's, I don't know, like maybe, I think maybe what he's trying to get at is what I was talking about with angular resolution. So the thing is, right, I'm talking about optics in relation to my point in space, and that would be relative to my lenses, my eyes. But if I was then to pull out a telescope, I am now changing my resolution. And that's why when you use a telescope and when you zoom in on something, you actually lose area around it. So this is actually a perfect explanation for how it works with things converging into the distance and things appearing to drop off over, drop off. And they don't actually curve away. You never could see a curve because it would be going away from you. What you actually see is the convergence of the sky and the ground, and basically the limit imposed by the Rayleigh criterion of those two objects merging into each other. And so, but there's, you have an intense angular limit there.
Any thoughts there, Allan, before we move on?
Yeah, I agree with what Toby said.
Okay.
Can I clarify the question on behalf of the questioner, please, Ryan? Because it sounds like the questioner was asking, like, if they have they brought up the black swan, whatever you're doing with the experiment, they're asking, how do you measure the distance to the other side of the water? How do you measure the distance to the oil rig? They're asking, how do you get the distance between where you shoot the laser and the other side?
Well, so if the convergence of things in the distance was caused by Earth curvature, right, then you wouldn't be able to bring them back into view by zooming in on them with a higher zoom optic, would you?
No.
You can't.
In other words, like you say,
there's
the
tons
oil
of
rig is
examples
10
of it.
miles away or whatever. How are you getting that distance is what they're asking.
Last word, Toby.
How am I getting what distance? You would never use
Like if you
optics to
have an
measure. You would
experiment-
never get a distance 10 miles away using optics. That's literally violates the way you're supposed to use a theodolite.
Okay.
So I don't know.
so-
Maybe you don't
So you set
understand the
up the
question.
experiment. The
No,
laser is
it's-
here, and the other side of the lake is a mile away or whatever. How are you getting the distance to the other side when you do the calculations? It is literally asking just how are you measuring the distance on Earth
Last
between the
question.
two
idea.
Last
locations?
question.
I have no
Darryl, sorry.
idea how the cartographer measured that lake.
All right. Next one.
Okay.
Unconditional truth. Can Toby and Allan each list their favorite experiments involving a laser in interferometry? I can't say that.
Interferometer.
Thank you.
Interferometry.
Interferometry. Thank you.
Interferenceometer.
Oh, thank you.
Yeah, I like to and prune.
And
good one.
say what the implications tell us about current globe dogma. Gee,
Yeah,
a word I
so-
can't say. How about that?
So the implication with that is that the speed of light is not the same in an inertial frame, right? Because we're told that the Sagnac effect is due to the rotation of the device. Therefore, there's a time displacement, with an observer being stationary at the center of the device or whatever, right? But what Dufour and Pruner did is they had the device configured such that it would reflect back on the lab wall, right? So, and that's where the source was too. So they took the fringe shift readings from a rotating platform that was just essentially like free rotating. And so the where the recorder is determines if it's an inertial frame or non-inertial, right? So if it's attached to the device, they would say it's a non-inertial frame, therefore special relativity doesn't apply, blah, 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 right? Or the inertial frame doesn't apply, right?
No.
But they had
Sorry.
it fixed to the lab wall. So from that, it's an inertial frame, right? So
Okay,
and
next one.
No.
it shows a shut up. It shows a fringe shift pattern that's proportional to the rotation of the device.
Do I get the
Do
answer?
you not know what an inertial frame is?
No, I have no idea. So
Okay.
you
Would you care to explain to me what an inertial frame is? Because you
listen,
seem to think that Earth fixed
wants us to play games with
inertial
him?
frames
I
are the
mean,
same
buddy.
thing.
Okay, dude. So an inertial frame would be stationary, non-rotating, right? Or uniformly
No.
rotating. Okay. Next question.
Yeah, that one was for you
I
I
guys.
would like
don't
to.
know
I
what
would
an
like to
inertial
Sorry,
interject
sorry,
on.
I'm
No,
sorry,
I'm not
Tony.
gonna get interrupted
Sorry.
mid fucking sentence, bro. So you can shit the bed.
All right, just 1 second, Alan. Well, like I said, we're going to try to keep it up here if we can. I know it can get tough sometimes when we're getting heated, but let's.
Would
let's
the
try to
other
keep it
guy
okay.
like to tell me what an inertial reference frame is?
No, I wanted to answer the question that was posed by the super chatter that they paid money to hear an answer to.
Yeah. Do you want me to repeat the question there, Toby?
No, so Dufour and Prunier,
Go ahead.
so with Michelson, Gale, Pearson, they say that they're able to measure the rotation of the Earth because they're using a closed loop. And then the only way that they can get away from remember when I brought up 2004 Ruyang Wang with the one-way the linear motion being measured in the fringe shift, the only way they can even try to invoke a Lorentz transform with that, or one of the ways that they do it, is to try and say that it's because it's a closed loop. You can't that doesn't, that somehow is a special rule for relativity. Closed loops, you can have the speed of light not be constant in the closed loop. But what they did with Dufour and Prunier is they actually they reflected the light out of the interferometer to, like Allan was saying, it was actually mounted to the wall, and they measured the fringe shift on the wall. So it's outside of the rotating reference frame. It's got nothing to do with the closed loop, and the speed of light is still not constant even when you come outside of that closed loop.
All right. Next one. Sorry. Now we're having a shift here, Tony and Darryl. A lot of questions for Toby and Allan. How can you claim what the shape of the Earth is when you don't have an understanding of basic grade 8 math or science? Oh, that one kind of got nasty at the end there. But yeah, we do try to read them.
No,
people get upset with me when I don't, and I apologize to those people that I don't read your chat.
Yeah, so let's see. What was the question? How can we claim what the Earth is if we're retarded? Well, I guess we can't. Good question.
Any other?
I can actually add something to that if that was such a short answer. And that's part of the point I was making. I watch almost every flat Earth debate that you all have on MBD, and every single one that comes on is just the surface level talking as if they understand, when even just the basic level of math and under science shows that they don't. And that's why the people who go into flat Earth usually have no education. They have
This one was for them. I'm sorry,
the people
Darryl.
who don't understand it are talking to the people who don't as well, and they all think it makes sense. So.
Did you have anything you
Did
wanted
this sound like
to
surface
say?
level to the audience?
Dude, I'm so glad you were able to come gaslight us on our question. That's super cool of you, Darryl. Much appreciated, bro.
Let's carry on. Unconditional Truth says, in case anyone missed it, can Allan and Toby please re-explain how longitude, latitude lines were determined on the globe model and why they do not prove sphericity?
It's just all based on celestial observations. Everything's using angles and celestial observations, and yeah, I mean it was a king's decree back in, I don't know, like 1760 something.
1776.
So yeah, I think I've heard a different number too, but the idea being that essentially they just mapped a globe from the sky, and unless we could actually go out and verify distances using something like Wang's speedometer, which would measure absolute motion, then we really can't say what the map should actually look like, because what we have, the AE projection, is flawed because you're taking what they did was they mapped the world to a globe using centuries of data, and then what the AE model is, so you've taken a flat surface and you've mapped it to a globe. So now when you pull it back out and you do that, just that automated transform, you actually have a skewed model. It's not necessarily going to line up with what if you were to actually make the map using the sky on a flat Earth, you'd have something that will look quite a bit different. But of course, it's not so easy to go map the whole world, especially the southern seas.
Okay.
Well, we did it. Why can't you?
Because I don't have centuries and a king's decree to do it.
All right.
Well, apparently, the people
Sorry,
who
this
believe
one
the
was
Earth's
for them,
flat
Tony.
for
We're going to try
thousands of years.
We're going to try to carry on and keep it to the side that has the question, because we have a lot of questions.
Okay.
And if we keep the back and forth, so we're going to try to address the people who are asking the questions, and try not to pull the other speakers in, because I know it's easy to make reference. So Medical Mass Media says the Kraken strikes again. Demonstride says to join the Discord for the after show at discord.gg/demonstride. So there's another after show going on in the Discord. So check that out if you haven't. And Unconditional Truth says, can both Allan and Toby give a few reasons why they do not trust NASA? Do they think government institutions have have as a record of being honest. We'll give you guys a minute on the floor, Allan and Toby.
Go ahead,
Yes.
Allan.
I don't give a shit about NASA questions, bro.
I'll go. I'm kind of on the same page as Allan, honestly, because for me, it's like I look at the Apollo 17 launch. That's all I really needed. Like, even way before I was a flat earther, I was quite skeptical of moon landing because of how basically when you start to see how many times they've deceived you about things in outer space, you really have to start questioning outer space. The fact that they don't put clear CGI watermarks on all of their CGI footage, I find insanely unscientific and insanely alarming. That's just a really minor thing. But if you go and look, you can see them messing with harnesses, you can see bubbles, you can see flies, a bunch of stuff that shows that they're staging all of this. And the hair doesn't make sense. But so regarding the government, yeah, I mean, you look at, I'm not going to get specific, but the last, however many years, it's been kind of crazy, right? So, yeah, I have a lot of skepticism of all of the major governments of the world. And then it's weird, like we're in this war with Russia, but we'll go up to the ISS and we're not going to fight up there. We're going to go to Antarctica and we're not going to fight down there.
All right, LJ coming in. This one for you, Tony and Darryl. He says, rest in peace to the spinning space ball with curved seawater fantasy. How do we detect airport moving sidewalks, but not 1,000 miles per hour spinning Earth below us? You want to start us out there, Darryl?
I could get that one, Tony.
Go ahead, 1 minute.
So, the way it works is we're sitting on the Earth right now, or standing on the Earth right now, spinning with the Earth. So if you jump up in the air, it's not going to suddenly run away from you. Similarly, if you're on a public transportation bus and the bus is moving and you like take a step or something, the bus doesn't just suddenly leave you. So I think this has been covered so many times. It's amazing that this is still being asked.
Yeah, because people want to know, like, how could I actually measure the motion, right? Like, we can't feel it, we can't see it. Helicopters don't account for it, planes don't account for it, missiles don't account for it. Literally nothing accounts for it. So we're wondering, like, how can we measure it? If you're going to tell me it's moving at, 66,000 kilometers a second, or what is it, 30 kilometers a second? It's like, come on, man. Like, I would like to know how I could substantiate that, and I haven't been given
So
a
how
way.
have you determined that all of these things don't account for it? Like,
You're trying to get me to like, you have to be specific, man. Which things?
How have you determined that these things don't account for it?
What
You
things?
gave a list of things.
You're repeating yourself.
things you
What
listed.
things? The things
things
that
you
I
listed.
listed regarding
Okay, we can move on. If you don't understand, if you can't remember what you said just 10 seconds ago, it seems like you're just running from the question. That's further as normally you do. We could just move on.
or gaslighting.
All right.
Man, I needed to do
I
it.
thought that this was our question, mate. Why the hell are you talking?
All right.
Oh, you waited for James to come back to complain.
So
Perfect.
the whole
Coming in, everybody's talking, so let's go
the
ahead.
human vestibular system has a limited observational accuracy. The accelerations that humans experience as a result of Earth's rotation, Earth rotating around, Earth orbiting the sun, or the sun's motion through the galaxy, are vastly below the threshold to be detected by our vestibular system. As I mentioned earlier, one of the central premises of relativity is that you can't tell that you're in motion internal to the system. You can only tell that you're in motion relative to something else by looking at the something else.
So then we would have a kinematic equivalence.
And why are you talking?
Geocentrism would be just as correct.
This is our question, right?
You paused, and I was trying to respond to you in a conversational,
You
friendly
can't.
manner.
Okay,
You
I'm sorry,
can't.
Toby. We do
We're
have to
not
move
allowed
on.
to.
At this
He
point, we
just
do have to
explained it.
move on. I'm trying to make sure, because like I know everybody's gonna just be like, oh yeah, we're fine to stay because everybody else is fine to stay. But really, you're gonna be thankful, like I say, if we can wrap this up in fair time. We do want to, like I say, get some meat on the questions. So let me just scroll back up here, and we're going to get a question for the other side. So make sure, if you haven't already, hit the like button. Once again, we really appreciate it. Boost us up in the algorithm. Next one coming in. Unconditional Truth says, oh, we already read that one. Mr. E-Man says, can Toby please explain how a model that does not exist, that has never been presented, and has absolutely no observational evidence to support it, be straw-manned? This one's just for you. 1 minute.
I guess I would have to know like what that's specific, particularly in reference to. I'm assuming he's talking about sometime earlier in the debate when I was accusing someone of doing a straw man. So I don't know. I'd have to kind of know what specifically that was about. But I may not have a full model to be bringing forward. What I am bringing forward is just clear evidence that 1, there's no curvature, 2, there's no motion, and 3, all of our understanding of geophysics is utterly flawed and based on a bunch of ad hoc understandings of things that are, based on assertions about things that happened billions of years ago that we could never possibly substantiate and actually have been shown to be utterly false in numerous ways over the years, but we just ignore them and sweep them under the rug. Like carbon dating, radiological dating. Yeah.
All right.
Magnetostriping on the ocean floor.
Let's carry on from there. And thank you so much for your super chat and Toby for answering. So let's carry on. Somebody asked, can you... they said, can you lower Tony's mic level? Too much rage. Well, you know what? We get excited sometimes during the debates. I do want to read all the super chats, but try to keep them friendly and actually relevant. Unconditional Truth says, Toby and Allan, how do appeals to authority, appeal to credentials, and appeal to a majority fallacies play into the acceptance of the current globe religion? I'm going to put the long cadence on there. There's no punctuation much.
Yeah. So if you're not allowed to question anything or figure things out for yourself, and you could just be gaslit into you don't have the credentials to look at it or whatever, then that's what maintains, the glob essentially, right? Because as we went through earlier, we went through interferometry. We talked about the fourth order interpretation of something when there's literally it's measuring a first order effect of motion, right? That doesn't exist in their model, and they're just like, nah, don't care, totally still believing that it's moving. So, you can just gaslight your way into anything, really.
All right.
Can I
Any
comment
thoughts?
on this topic, Ryan?
I'm sorry, Darryl. We gotta try to move on, but the next one we get for you guys, we'll give the floor
Real quick.
over you, Toby.
Can I respond to it? Or
This one's for you guys, so go ahead, Toby.
Okay. Wait, should I go now?
Yeah, go ahead.
Okay. So I would just say, it's a perfect system that they've got set up. You've got high priests that have the math that you're not allowed to understand. And then they're going to tell you that you're too dumb to know it. And that's a perfect control mechanism. It's literally like they have their own documents that they say that they're too complicated for us to look at. So yeah.
All right. Witsit Gets It. I don't know what your interactions have been with Witsit Gets It, Tony, but he has accused you of interrupting the entire debate, and he's asking you why. Did you want to say anything to Witsit, who's on here often debating this subject? Did you want to carry on?
Well, Witsit actually makes it a point to interrupt every other sentence that somebody says with some sort of fallacy that he doesn't understand. But also, I just object to being lied to. And if somebody starts with a premise that I know to be false, they cannot have a valid argument. So if they say something that I know for a fact is false, I want to stop them there because the rest of what they're going to say is invalid because they've started with a falsehood. And in particular, the central falsehood here is that Toby and Allan assert with no evidence whatsoever that they have the credentials to properly understand the scientific literature. This is what exams are all about. And, they can talk about it as though it's gatekeeping. They can talk about it as though it's some sort of oppressive measure. What it is some attempt to keep science grounded in observational reality. And this is the thing that they've missed. They keep on talking about stuff for which there is absolutely no observational validation, such as the ether. They mention it over and over again. Absolutely no evidence it exists.
All right, thank you so much, Tony. Next one coming in from Mark says, after show on Witsit Gets It. Another notification there for that. And it sounds like, he says, Tony, take your... I think I'm colorblind, but I think he's saying red pill. I'm not sure. But either way, I think you're invited over there to have a chat, but you're always welcome here to have that chat with Witsit on Modern Day Debate. That's always fun. So LJ coming in $4.99. And I forgot to mention, LJ is our honorary Flat Earth questionnaire. He always, even when we're not having a debate about Flat Earth versus Globe, comes in to ask about the heliocentric model. So LJ, we appreciate you. Why is Flat Earth the #1 censored topic? As a moderator of many Flat Earth debates, I kind of take contention with that, LJ. I mean,
well, to me, this is, well, I'm glad you asked. To me, this is one of the most dangerous and pernicious things. If you accept if you reject the objective evidence we have regarding the shape of the Earth, you can reject anything. To criticize the government for lying to us, fine. Yes, the government does lie to us, and we should hold them to account. There are misdeeds by politicians and by government officials, but if you're prattling nonsense about the flat Earth, you're not actually holding the government accountable. You're distracting energy and effort that could be going into making the world a better place, more constructive place, and you're directing it into a deranged fantasy. And that's the bottom line here. If you remove yourself from observational reality, I brought in observations about the propagation of earthquakes. I brought in observations about rail track lengths. I brought in observations about navigation. I brought in all of this observational data, and they just ignored it.
We brought a bunch of substantive specificity.
Rather they asserted with zero evidence again that they properly understand and have interpreted scientific literature that they manifestly have not.
Any thoughts, Darryl, before we move on?
I could just second that with Tony. I mean, there's this discussion as if I believe I heard Toby say, "Oh, they're saying we're not allowed to understand math." This either you can understand it or you don't. There's so
the rules are you're not supposed to invoke your opponent. Then now I have to let them respond.
I thought it was.
That's the rule.
It's more gaslighting. The audience knows that's all he does is gaslights. It's all good.
At the end of his statement, Toby, go ahead, Darryl. Sorry.
Yeah, so I mean, it seems really, really relevant. So there's nobody saying that, and like for instance with NASA, I had a brief experience of when I was in community college of being in a learning experience with NASA, and to be able to see a little bit of what they're doing and what they're working on, and the ingenuity and the effort and the higher level that goes into what they're doing is amazing. That people just say, I don't believe NASA, but the fact is anybody can do their own science and math and understand what's going on. So,
all right, let us carry on. And thank you so much for your super chats, and thank you for wrapping that up for us, Darryl. Let's see. Witsit Gets It says Darryl actually said that MMX had nothing to do with motion. Ha ha. Okay then. What did they use specifically to get their predicted fringe shift value? Tried to do you justice there, brother.
MMX?
Yeah, that's what
Michelson-Morley experiment.
Oh no, I didn't say that. So it sounds like there was a misunderstanding. So I didn't say it had nothing to do with motion. What I said was, which is what the paper said, and which is what the understanding is, that they were measuring relative motion between the motion of the Earth and the ether. I didn't say it didn't have anything to do with motion. What I'm understanding from various flat earthers, they try to say is measuring the motion of the Earth, period. When the paper itself, as we show looking at it, that's not what it's saying. So it definitely has to do with motion. It has to do with relative motion, not just the motion of the planet, which was already understood to be going on. They were measuring it, and they also mentioned ways to measure it relative to the solar system using the orbit of Jupiter's moon. So all throughout the paper, it's clear that they recognize that the Earth is a globe orbiting the sun, and so on and so forth. The contention was whether there was ether.
Thank you so much, Darryl. Witsit Gets It, and I'll let you pick up on this one, Darryl, says, and why are you guys ducking the linearized Seismic effect?
That just didn't come up. So, I mean, looking at that, and that's another one, by the way, who reads these papers and doesn't understand what he's talking about or doesn't have the necessary understanding to see what's going on. If you look at the paper and read what the Wang paper, the first one, the generalized Seismic effect, they were simply pointing out the fact that they could do it in a linear fashion as well. So he actually talked about the fact that for navigation, some of these they could utilize the circular and the linear one at the same time to increase accuracy. So I didn't see anywhere in the paper where it spoke anything to the effect that Seismic is linearized now and there's no motion or like that. He was simply saying that it could also be done in a linear fashion and in the first order fashion, using as far as the Wang second paper to get different results.
That would have been 1999.
This is our question.
30 seconds over to Tony.
Okay. The central issue here is that they don't understand the term linearized. A first order effect is algebraically a linear effect. So it is linear in terms of the variable, but the variable here is the velocity of the planet divided by the velocity of light. Can you shut up, mate? So it's just a first order effect in that. It's not saying anything about the linearity of the velocity.
Please reply.
We gotta.
Please. I gotta beg you to reply because he just totally misspoke. It has nothing to do with the linearity of the variable. It's literally linear motion through the waveguide loop.
All right, we let that one go, and let's just carry on, fellas. And I'll let you have the last word there, Toby. How do you say your name? Your name is more complicated than some of the terms that have been coming up in here. What is this? Fistruliness? Ah, man. Toby, if you disagree with the experimenter, you should do your own 100% flat Earth experiments instead of this cherry picking and misunderstandings. More of a declaration and a statement, but I'll give you a minute to respond to Hanis.
I mean, the audience heard the debate tonight. They can make their own judgment about who's misunderstanding things. I mean, that was kind of just like a gaslighting question anyways. Like, I almost don't even really want to entertain it. What was the substantive question again? Can you please remind me?
I asked you to do 100% flat Earth experiments instead of cherry picking.
Oh, yeah, experiments. I mean,
yeah,
literally every experiment that gets done just gets explained away anyways. Like, it's been done over and over and over and over again. It just gets explained away over and over and over again. You either invoke a refraction that magically curves around the Earth, perfectly relational to the way that it would make it appear that the Earth's actually flat. With relativity, they just invoke Lorentz transforms that you literally can't unsubstantiate. Like, the thing is, like what I like to say about this when people bring this up is I have nothing to actually go dispute, right? I do not dispute the fact that in a theoretical universe that there's a theoretical reference frame in which light is constant. I do not dispute that. It's a theoretical reference frame that can never be falsified, never be substantiated. It's philosophically just totally bunk, but I can't dispute something that's philosophically totally bunk because you can't even use real logic to dispute it.
All right, let's carry on. I am for $4.99 says Darryl claims MMX has nothing to do with Earth's orbital motion, but not to mention the title.
You've been through that one.
Did I?
Oh no, that the other one was from Witsit. Sorry.
Yeah, no.
This is a different question, but the same.
Yeah, I was gonna say this is a different one about a similar topic. So he says Darryl claims MMX had nothing to do with Earth's orbital motion, but not to mention the title. It's mentioned in the first half of the first paragraph. And that's their 10th super chat. Thank you so much for that.
So, are you wanting me to respond to that one since it's similar?
Yes, sir.
So the same thing as before. When you look at the paper, it clearly talks about the relative motion. Okay, so it talks about the Earth, the Jupiter's moons. It talks about the motion of the solar system. It clearly shows that it understands that the Earth is moving. It was talking about the relative motion of the Earth to ether and testing that. The no result was the fact that it didn't find ether. So I don't know where people, I guess, sometimes mishear, but I never recall saying, Tony, did I ever say that it was not about motion at all?
I don't think so. I don't know where they're getting this from.
So I don't know where they're getting this from, but maybe rewatch it and listen a bit more closely. Whoever's the people that keep asking.
I mean, Tony said the motion literally didn't matter.
For them,
Tony conceded geocentrism.
Toby, please. I'm sorry, Toby. I don't want to mute you, but you can't talk over me. We're gonna carry on. I'm gonna just take you off the mute there. I had a follow-up question. This says the effect was attributed to a simple composition of the velocity of light with the velocity of the Earth in its orbit. First paragraph, MMX. We'll give you 1 minute there, and then we'll carry on.
Yeah, so I mean, same thing. It talks about the motion of the Earth, the motion of Jupiter and its moons, relative motion of the solar system. So it's talking about motion, and those things are moving relative to the ether. So I mean, I don't know how many times we could beat that dead horse.
I'd like to say
you
something.
add, Tony?
Yeah, I do. The claim made multiple times that I have considered geocentrism is a barefaced lie. What I have said is that the evidence relating to the geometry of Earth is unrelated to the evidence, is independent of the evidence relating to its motion. And the fact that Toby can't seem to understand that, does rather illustrate his inability to correctly interpret scientific literature.
You've been invoked, Toby. So if you can come off mute, you can dig into this.
The fact that I don't understand what was it?
You weren't listening? Oh, what a surprise.
No, yeah, I was looking at something on my computer. I missed what you said.
Yeah, well,
2
maybe
seconds
pay
ago.
attention to what you're doing.
Okay. Now, will you repeat yourself for me, please?
Nope.
All right,
Okay, we can move on, James.
let's move on. All right. And just a reminder, I am Ryan. I know it says James on the Zoom chat, and yeah,
You know, and I
messes
knew
everybody
that.
up.
Sorry.
It messes everybody up all the time, so don't worry about it. It's a really minor thing, and everybody in the live chat, you behave yourselves. I know that I might look like James. I might be as buff as James, but I'm not. I'm kidding. Obviously not. All right, so let's see. We got other questions. Witsit. Oh wait, we got other ones from Witsit. Let's keep scrolling up here. Don't mind me, everybody. Lazy thumbs who haven't hit the like button. I'm calling you out. All right, so LJ says, why don't we have non-CGI footage of space in 2023?
We do.
I could get that one. Go ahead and show us. So I showed some photos in my picture. Show us how they're CGI. Let's start there. I always get these. To me, it seems like a very dishonest question. How we don't have any pictures that's not CGI when I've never seen any of them show where any picture is CGI. It's just a baseless claim. Why don't you show me a CGI? Why don't you get your evidence that they're CGI? Contact NDD and I'll come on and talk with you about it. How about that? You want to talk about it, Tony?
If anyone actually
Yes,
wants to
I
do an
do. Can
investigation,
I
go
share my
check out
screen
Rough
for a
Polisher.
moment?
Well, we are trying to keep it brief for the sake
Yeah,
of you
it's
guys'
just
time
one
constraints.
slide.
But go ahead. We'll give you 30 seconds. Go ahead. Once you get
Okay.
your screen share up, we'll start the timer.
Okay, so these photos were taken in 1965. You provide the evidence to me that these were CGI'd. Further, provide the evidence to me that it was even possible for them to CGI these images in 1965. You can't do either of those things because it wasn't.
All right. Well, thank you for the quick screen share there. I appreciate that. And you guys are going to appreciate it too, because like I said, I've almost gotten to that point where the scroll bar has hit the halfway point. That's where you guys are at. So
Hey, let's speed it up, brother. Get out of here.
I'm doing what I can. I'm sorry, Alan. I don't mean to be keeping you guys, but
Super quick, brother. Read real fast. Get in there.
I can do it. I won't waffle anymore. Even though last time I was on, McToon called me out for waffling while I scrolled, and I messaged him after and asked him if he'd like some maple syrup with all my waffling that I do.
Well, bro, you're not reading. You're fucking talking.
Yeah, I know, right? I had to scroll. Hold on a second here. Isa Kabir asks, first question, all panelists, please explain the different level order measurements with experiments. All right, we'll start there, Isa. So 15 seconds, Toby.
So is it a direct measurement or is it not? Are you abstracting from it or are you not? It's essentially, that's when you get into the fourth order, you've gone through 4 layers of abstractions, right? The reason that they try to say that the Michelson-Morley interferometer is not a first order
3
measurement
seconds.
is because you actually have to, it's reliant on the 2-way speed of light. And so they have to make an assumption about what the 1-way speed of light was.
All right.
It's a closed loop, right?
15 seconds over to you, Tony.
Okay, no. A first order experiment means that the effect that you're trying to isolate in your experiment is of first order magnitude in the algebra. That's the whereas a second order
3
experiment means that it's a second order term in the algebra.
Time.
Third order term it's got nothing to do with what was just suggested. That's
So
a
you wouldn't
complete
have to do algebra to deduce the 1-way speed of light from 2 ways?
This is for all panelists. So 15 seconds on the floor, Darryl. All panelists, please explain the
I could
different
just second what
level.
Tony said. That's exactly what I was talking about, the Taylor expansion. The Taylor expansion, the first expansion, the first order, second is the second order, which would be a slope because that's the first derivative, and so on and so forth. So it has nothing to do with what you're talking about, which is why they don't understand what's going on with these papers and
3
why
seconds.
some papers disregard high orders and some papers accept lower orders, like
Time.
with the like with Wayne's second one. Thanks.
Thank you so much, Darryl. And last word, Allan, 15 seconds on the floor. Please explain the different level order measurements with experiments.
Oh yeah. So I agree with most of what Darryl said, and I also agree with what Toby said. That's my contribution.
All right, thank you so much. Let's see. Matt Urquhart says, "Flat Earth. Is it possible for a Haversine formulae to accurately describe all shortest path distances on a flat surface in Euclidean space?"
Dude, that's a great question. So we do have a linearized Haversine formula, but I can't present that right now. But the answer to the question, though, the Haversine formula and the use of it would derive. That's how you derive distances on the globe, right? So this is what they're looking for with it. But yeah, we actually have that now. It's forthcoming, but yeah.
Any thoughts over there, Toby, before we move on?
Nope.
Yeah, no. All right. Let us carry on. So I'm just checking in on you guys in the live chat, making sure you're behaving yourself, seeing who all is still hanging out. What's It Gets It asks, Darryl, you just got exposed after claiming you understood it way more. Answer the question. What is the proportional velocity being measured in mmx? Let's do 45 seconds going forward.
Certainly, they were measuring the relative motion, or trying to measure the relative motion of Earth to the ether. My purpose of reading the paper was not to understand it completely because this was my first time reading it. It was just to look at it and show that you don't understand it. And just like I've seen you present papers that you don't understand as well with it. So it's a common theme in Flat Earth, as me and Tony pointed out, and they demonstrated for us over and over again. So.
All right, let's go back to Issa's second question. And he says, what is the place for credentials in Flat Earth versus Globe? To all panelists. So 15 seconds over to you, Toby. What is the place for credentials in Flat Earth versus Globe?
It's really complicated. I think in some cases we have to invoke people's credentials just because that's what people are used to, and that's the system that we, in a lot of ways live in. But at the same time, we saw Tony not even understand the computations of the 2D versus 3D waves, and that's apparently his profession. So you can't always just rely on people's credentials. That's a fallacy anyways. It's not a way to live your life. You need to go investigate things for yourself and trust your own instincts, trust your own intellect. And if you don't understand something, that's okay. But that doesn't mean that just because I don't know. I'm okay with not understanding things. I'm not out here lying about understanding all this. That's silly.
Yes, you are.
Okay.
So to me,
Question
yeah,
was-
well, you just made an assertion
Yeah,
about me
15
not
seconds.
understanding stuff. So the option that this was going to be a polite interaction has long passed. So let's apply this guy's methodology to flying a plane. So you don't need to listen to instructors. You don't
10
need to
seconds.
read manuals. You can just get into a plane
Did I
and
say
just
that?
fucking crash it. You can go and do brain surgery because apparently you don't need qualifications to do brain surgery. You can just wander into a hospital, do it yourself. You don't need to study. You don't need qualifications. You can do it all yourself. That's not how
It's time.
anything works.
All right, over to you, Darryl.
An analogy that comes to mind is martial arts. Sometimes you'll hear people say, "Oh, a black belt is just a belt," and that's usually coming from people who didn't train in martial arts. So about the same thing, people don't get a qualification normally just because it's granted.
3
It's a
seconds.
demonstration of the learning and experimentation that was done to develop the understanding. That's what it's about.
Hell yeah. I'm going for my black belt right now. So I've got to just keep working out so I don't keep hurting myself. Allan, last
So is it just
15
a belt, Ryan? You let us know. Is it just a color? Is it just a color? Is it the same as a white belt, or does it actually matter?
Oh, no, you
Does
could,
that credential stand for
I was
something?
going to say most people could probably kick my butt. So yeah, Allan, 15 seconds on the floor.
Yeah, so I 100% agree with what Toby said, and I 100% agree with what Darryl said. And I didn't agree much with what the other guys, Tony said.
Okay, awesome. All
Yeah,
right.
I just want
Next
to point out
question,
something quickly.
please. No.
Yeah, we should move
brother.
on to the next question. We are, like I said, just a little over halfway. And yeah, just because I can teach kids how to kick does not mean I'm a great fighter. So, Space Miner says, Ryan, you're awesome. Hey, that's a great comment. Thank you, Ryan. You're awesome. Don't forget your power to press the issue as well. Moderator has a say where the debate goes to. I mean, I have thoughts about that, so maybe I'll respond right quick, Space Miner. We try to let things be as open as we can on modern day debate. We want to make sure that we keep things on subject. We want to make sure that we're keeping things cogent, polite, and somewhat juicy and fiery at the same time. We don't want to completely choke off our speakers and say you can't be your personality on screen. So you know, I try to interact when the speakers ask. Like when Toby asked for a minute, I'll give you a minute. You know, you just got to ask. Just how she goes, and I'm not shy about it. So,
Ryan, you have the patience of a saint. Don't be shy about it.
oh, thank you. I was gonna say, yeah. Ultimately, I am in total control. I can kick people out. I can mute people when I need to. I'm just very chill. So, Witsit Gets It asks, why does GPS have an account for C plus V for both?
C plus or minus.
He wants to ask
Well,
Tony and Darryl. I think they're sorry. It's
okay. Well, that features into the distance calculations. I don't understand why that, you know, I'm not an expert. I work with people who are experts in GPS who have written their own inversion software. They use GPS to track the motion of continental plates. I've been on a GPS survey, but I'm not into the weeds on the formulation, but it doesn't matter. The reality is GPS works. You want to demonstrate that flat Earth. You want to demonstrate flat Earth. Use GPS to demonstrate a flat Earth. Show me that if we put a GPS on a ship, that the ocean doesn't curve, because it does. Show me that you've got some other way of doing things. And I know, I like this. Oh, we've got a distance formula that's going to work. Trust me, it's over there. In the cupboard. Don't ask to see it, because God alone knows. We never do anything in the real world. But yeah, it works. I don't know the details of it. So there.
All right, let's carry on. And Jams said, Ryan is so beta. I love that.
Tony, I'm
It's
sending
fun.
you an Excel sheet on Discord real quick. It has the Haberstein formula. You can take a look at it.
And somebody else asked me to say it with my chest. If I say it with my chest, then it's going to be a real nightmare around here. Like I said, I'm going to play that tune at the end of the
Are you on
chat.
medicinal mass media, Tony? I could put it in the general
Nope.
chat there. Oh, okay.
Oh, he's in our Zoom chat. If you want to post anything in there, that's cool.
Can you send Excel files? Well, I guess you can, right? PDFs. Let me try.
With Tony's consent, I can connect you guys via email if you want to send links back and forth.
Sure.
Yeah, if you want to actually have it, but I can't share it unless, it won't let me drop it in.
Okay.
I have to email it to you.
I'll connect you guys via email once we're done. Howard Moore asks, with the actual documents being read, reflecting intent, method, and conclusions, will Toby, Allan, and Witsit continue to misrepresent them? Bring Witsit in. My goodness. Go ahead, guys.
Yeah, I mean, Jesus.
I don't really agree with that. And, I think that I'm going to defer to what Toby says for my opinion.
Yeah, I mean, that's your opinion. I would bet that if we were to have a debate about this topic, that you haven't even done any surface level investigation into it. If you have a substantive contention with something that we've read into, you can go meet us up on ethercosmology.com, ethercosmology YouTube. We literally read the papers live on the air, so you can leave your comment down there. We may or may not comment. We try to when you're actually acting in good faith and asking a question in good faith. But yeah, we definitely don't misrepresent any of these papers. And the fact that you didn't, like, if you actually saw something there that you knew substantively we misrepresented, then you would have your super chat would have been a very excited super chat to tell us why with substance what we did was misrepresent the paper, right? But you didn't do that. Instead, you just had to make yourself feel better by saying that we must be misrepresenting these papers because that's the only way that the ground beneath your feet can be moving and you can be on a spinning space ball tilting, wobbling in the corner of the universe.
I'm glad I deferred my opinion to Toby. Well said.
All right, thank you, Toby. And next question coming in says, Witsit Gets It. Tony, you said word salad 10 times. Can you define it?
Well, there are two there's a technical definition where word salad is the babbling of a mentally ill person. And there is a colloquial use of the expression in which it's just a sequence of meaningless jargon. For instance, the last time I got to talk to Witsit, he introduced the phrase centrifugal divergence, as though this is physically meaningful. as though it has some sort of scientific value. It's utterly meaningless. The only person who uses this is Ken Wheeler. It's not in any scientific literature whatsoever. It's not in any textbooks. It is devoid of meaning. It is word salad. And the
It's
fact that
measured
Whitsitt
geometry on a
and the
magnet.
other Ken Wheeler fans swallow it whole, yeah, that's why they shouldn't be trusted. That's why their scientific opinion shouldn't be trusted.
I better turn my preamp back on. See, this is a mic that needs phantom power. I got a little button there. Gotta be careful.
It's just a description of pure potential from a magnet, essentially, of a magnetic field.
Well,
No, it isn't.
thanks for pulling us full circle. Matt Hightower says, one. All right, so he's got two questions here. One is SpaceX also in this conspiracy to fake space? So, Allan, first thoughts.
Yes. And then also going to go ahead and defer to Toby for any additional information regarding the faking of space.
Yeah, I don't know, man. Like, I'll just say, like, from my own personal perspective, once I realized that I could even invoke the idea that the ground beneath my feet's not moving, and let go of all these Einsteinian paradoxes, it was really good for my cognition. But yeah, I don't trust Elon Musk. I don't trust SpaceX. I think that he's done some cool things with free speech, kind of, it seems like, but he's clearly in the club. He's clearly been propped up. He used Tesla as his piggy bank for like
10
a
seconds.
decade there. Yeah. And he was held up with all that. I think he's tied to Bitcoin too. He was part of the original PayPal crew. The fact that the Bitcoin, that the person that created Bitcoin is a mystery is not a coincidence. That's CIA by design.
All right, and the second part of this question is, what the F am I seeing when I look up and see a string of Starlink satellites orbiting the Earth if they are not in fact orbiting the globe planet?
They're just flying by in a line. And that we didn't really get into perspective very much in the way that we perceive the sky and the way that things converge into the distance as they so that's why things appear to go up and over you and down, because it's actually as they come out, they emerge from your angular resolution point, right? They emerge from that, and then they come over you and they go over top, and it looks like an arch, and then they converge again back in the distance. And that's actually why with the sun, it's kind of like what you see with crepuscular rays, right? They come out from one side and then they go over you and they go back to the other side. And those are actually straight lines, but they look to be curving because of the way that you're looking from a single point in space out through a 3D world.
All right, any thoughts there, Allan, before we move on with the 20 seconds?
Yeah. We can go ahead and get the next one.
All right, thanks, buddy. Let's see what we got. We got Unconditional Truth. Says, can Allan explain the implication of Newton's bucket?
Well, you got your spinning bucket, you got your laws of physics, which are all derived on a stationary, non-rotating, inertial frame. When Newton was spinning the bucket, he said, well, there must be an absolute space somewhere. It's definitely not on Earth because I'm a Copernican lad and I believe in all this motion that's never been measured or anything like that. So, absolute space must be somewhere. So that's a quick TLDR on the bucket.
Okay. They also ask you, what is the importance of the lab frame?
Well, the lab frame is where all the laws of physics were derived. So super important.
All right. And Allan and Toby, what does Newton's bucket tell us about physics?
It tells us that there is an absolute rest frame, but where is it? Where can we find it? Is it in the stars? Is it on Earth? We may never know. It's on Earth.
Yeah, just extrapolate a little bit on Newton's bucket, right? The idea is that you have a bucket with water. I know Allan went through it really fast earlier, but you have a bucket with water in it. And as you spin the bucket, the water will start to go up the sides of the bucket, right? And so say you put someone inside the bucket, you have to say it's a giant bucket, and you put someone on the edge of the bucket. Well, to the person on the edge of the bucket, they're not going to be able to tell whether they're spinning or whether the water inside and the person inside is spinning. And to the person on the inside, they're not going to be able to tell whether it's, the other way around. But the thing that is different is that the water ran up the sides, because that's the dynamic effect of the actual motion. So there's a difference between, these reference frames cannot be purely transformed from one to the other. They needed Einstein to do that.
All right. Witsit Gets It says, Darryl, can you explain why there is constantly, in caps, a fringe shift measured in mmx? I'll start there.
I would have to look at the paper again to see if that's even true. I found that Witsit doesn't always tell the truth, so I won't take his word on that's what it says.
Yeah, the authors of the paper attributed the signal that they detected to experimental error. And I don't see Whitsitt is adducing no evidence that their opinion should be second guessed. He's just asserting that experimental noise should be accepted as though it's real.
Well, he
And
asked.
that's not how science works.
Sorry to cut you off there, Tony, but he did follow up on that question. He says, doesn't a consistent detection directly refute heliocentrism / relativity?
No. The fact that you consistently get non-zero noise doesn't mean that there's a signal. You can let's take an example of rolling three d6 or 3 6-sided dice. My prediction, the most accurate prediction possible, is that the average is going to be 11, but the error, that's the best estimate that you can have. But the error is just going to be some random number somewhere between 7.5 and a half. So, even though our theory is absolutely correct, our experiment produces error. That's just how experimental noise works.
All right, we got to move on.
No, you don't get to talk.
We got to move on. I'm so sorry there, Toby. Yeah, I saw you put your hand up, but yeah. Eric Walters Waters says, Flat Earth says the sun sets over the horizon because it's far away. If it was simply far away, couldn't I still see it with a telescope or something? Toby, first thoughts.
I'm trying to think of how I can tie in Dayton Miller with this question. Maybe if you were to take an
Movement of the sun?
interferometer, huh? No, okay,
Movement
I
of the sun
won't do that.
periodicity?
I
Come
really
on.
wanted to reply to the last question, but in any
I
case,
know.
so with this, it's simple. It's convergence into the distance. I explained it pretty explicitly in the beginning. I'm sorry, maybe it's not simple. Sorry, but essentially, as things get further and further away, the relationship of the way that they disappear into the horizon, that point where they start to turn, they start to compress into the point where you can't perceive them anymore.
5 seconds.
That relationship is actually not linear. It's like a parabolic drop off. When you hit that point where you're losing resolution, you hit a point where things can no longer be seen.
Allan, any thoughts for the last 10 seconds?
Yep, what Toby said. Next question.
Okay, I am moving into 30 seconds to move out some of these super chats. So, RM, two globe and flat, is math science? We'll just keep it yes or no. Is math science? Toby? Yes or no?
No, it's a different field. It's a different thing. Math describes things. Science explains things.
We'll keep it short for this one. Is math
what Toby
science? Thank you, Allan. And Tony, is math science?
No, mathematics is the language of science, or to put it another way, mathematics is deductive, right? Whereas science is inductive.
All right. And Darryl, is math science? Yes or no?
No, it's a tool that science utilizes.
Okay. Thank you. Mike Jones, I guess I shouldn't say yes or no.
Oh,
Yeah,
wait. Before we move on, I also agree with what Darryl said.
Cool. All right. Yeah. Agreement is always a great thing on the stream. And you know what? I've hosted Allan before, and I got to appreciate you for being an amicable dude. Sorry, I have to say that properly.
Well, thank you, sir.
Yes, I appreciate your attitude. So, Mike Jones, I think it was done in a Faraday cage, and you're going to have to prove it wasn't, Tony. That's in quotes. Oh, maybe it was done in a Faraday cage. Also, Tony, 1 minute later. So, Tony, this person's coming right at you. They're putting in quotes.
I mean,
so
this completely misses the point that I was making, which is that Allan was asserting that an experimental effect that he was completely unaware of, given 20 seconds to actually look at it, he decided that this was due to changing electrical potential. Now, he could demonstrate that by doing the same experiment at a variety of electrical potential gradients, but he's done absolutely none of that. Instead, he's just made an assertion and completely overlooked the rest of the observational database.
All right, thank you so much. Which it gets it. Tony, can you explain GPS Meridian corrections? 30 seconds.
Meridian.
Meridian corrections. No. There you go.
Okay. JD, another one for you, Tony. Hold on. I'll come back to you. Leo Crow, never once in human history has nuclear fusion on the sun been proven. The axial rotation of the sun disproves it completely. This is another one, I think, for you, Tony. Why is the heliocentric model nothing but paradoxes? 30 seconds, Tony.
Well, we can prove that the spectral lines in the light emitted by the sun do correspond to fusion effects. We can confirm that there are effects. There are subatomic particles being produced and emitted by the sun consistent with a fusion effect. We can also notice mass being ejected from the sun, and that mass takes 3 days to reach Earth. So the idea of a local sun is completely disproven by that alone.
Okay, thank you so much for that. Darryl, did you have any thoughts before we move on?
Pretty much touched on it. I mean, we could examine the sun. I find that the flat earthers, they make these claims but do no astronomy whatsoever. So, I mean, Tony covered it.
Okay, well, thank you so much.
Yes.
And
I do want to return to Whitsett's question.
Which question?
The question about meridian correction.
Oh,
I can find no publications on this subject.
Paul Marmot.
So I don't know what he's talking about.
Whitsett has asked a lot of questions, to be fair. JD asks, my goodness, yeah, that's another one for you, Tony. I want to get one that's maybe for somebody else, and then we'll come back. Flat Earth, do you agree 1 degree equals 69 miles?
Yep.
I don't know. I've never verified it.
Okay. Let's see. Having a degree only proves you can memorize books is a statement by LJ. Coming at Darryl and Tony. Any thoughts about having a degree only proves that you can memorize books?
It's absolutely untrue. The critical having a degree has 2 things. One, you are educated with facts that you can recall, but 2, your ability to apply these facts to solve real world problems is critical. So it's the second element that is the critical part, being able to think critically and apply scientific facts to real world problems. And this is where Flat Earth completely falls over. There is not a single real world problem that Flat Earth has solved. They can't navigate, they can't calculate distances, they can't do anything. So of what scientific value is Flat Earth?
Okay. Next one coming in. Actually, yeah, that one was for both of you. Did you have any thoughts, Darryl, about having a degree only proves you can memorize books? LJ's always coming at.
I guess I do have a thought. Right now, I currently have 2 associate degrees, summa cum laude. I'm a senior working on my double in physics and astronomy. I can tell you it's not only about memorizing things. Going back to my analogy, that's somebody who obviously never did martial arts, in other words. So, I mean, we have to not only learn and we do have to memorize stuff, we also have to apply, like Tony said, consistently. In physics, we have to do labs. I myself tested Newton's equations and tested by measuring things fall and had to calculate things. I myself used a spectrograph and had to calculate the lines of helium and nitrogen to show that these lines come from gases that are electrified, which Tony referred to when how we know things are in the sun. So these things we have to learn how to do ourselves to even understand and to understand enough to get our degree. So it's just simply not true.
All right. JD coming in says, PhD Tony Less, in quotation, he says, still sober? I'm not sure what he's trying to say here. He says, brilliant job showing how wrong flat earthers are. JD, I can only assume that you're just making huzzah for Tony, so thank you so much for the fan super chat, and we'll carry on. Whitsett Gets It says, Tony, can you explain GPS? Yeah, we just did that one.
Again, that's what I looked up. No publications on this, so I don't know what you're referring to.
All right.
Paul Marmot and the constant velocity of light. The constant, yeah, GPS and the constant velocity of light.
Well, show me a publication.
That's the publication.
So Geocentric Truth asks for They accuse you of being angry, Tony. They call you Angry Tony. Well, explain why we see less stars when you fly at night in an airplane. Anything to say to geocentric truth?
Yes, you mean fewer stars, but the reason would be glare off the inside of your window. It's as simple as that.
All right. There you go. He's not taking the bait, geocentric. You're going to have to try again. Mike Jones says the Vikings who got blown off course to Canada were doing transatlantic voyages. Dash Tony. They're quoting you again.
Yes. Well, they were trying to get from Iceland to Greenland, right? That's not a transatlantic voyage. They got blown off course, and so that's not a deliberate voyage. They got blown off course to Canada, and then they sailed back to Greenland. Sailing from Greenland to Canada is not a transatlantic voyage. You're not going across the entire ocean, so it's not a transoceanic voyage. You're island hopping.
5
You're
seconds.
going from Iceland to Greenland to Canada.
All right. That's perfect
Oh,
time right
Canada.
there. Oh, Canada. Yes. I'm here and I'm loving it, honestly. Like, it's not a bad place.
Boo.
Boo. Yeah, you can boo me all you like. All right. So, so Unconditional Truth says, Darryl, actually, before we ask this one from Unconditional Truth, let's try to pass it over. Eric Walters says, for the flat side, who is masterminding the globe conspiracy and what's their motivation? Who all is officially in on the conspiracy? We'll give you guys 45 seconds between the two of you.
Is it a list of the lads that are in on the conspiracy? Is that the question?
Well, here I'll stop the timer. So, who is masterminding the global conspiracy and what's their motive? Who all is officially in on the conspiracy?
Oh yeah, nah, I'm good on that. I defer to Toby or anyone else wants to answer it. Darryl, you want to take a crack at it?
I could speculate like all night about it, but what good does that do anybody?
All right, you got it. Let's see, Unconditional Truth then. Darryl, if lasers you guys said this earlier. Oh my God.
Laser interferometry.
Were to show a correlation between the emotions of the celestial bodies and fringe shifts, would that falsify relativity?
Well, I can't say I understand the correlation between that and relativity to say it would have any effect. So this is one of the things that I hear flat earthers get wrong, probably intentionally. So, relativity is basically an over-encompassing system that encompasses Newton laws that basically could calculate motion at relativistic speeds and things like that. So I don't see how anything like interferometry would nullify it in any way. In any sense, it reinforces it by the fact that the time is different in different directions according to if the device is moving. And we had to calculate things like that in my modern physics class when I actually learned relativity and about proper time and reference frames and Galilean transformations and so on and so forth that these guys currently haven't learned. So I don't see the correlation.
Sorry to cut you off there. It says, so Tony, why did you duck that it would work on a flat Earth if you account for a time differential? Your model requires time differentials and speed assumptions. 30 seconds.
No, it doesn't. So our model doesn't require time corrections. It's the flat Earth model that requires the time adjustments that are applied arbitrarily, and there's a distance out to which that will work. It won't work indefinitely. As for the assumptions of velocity, we actually have observational data. We have rocks from volcanoes. We can take them into laboratories, subject them to pressure and temperature, and examine the passage of seismic waves through them. So we can determine their seismic properties and their seismic velocities observationally.
Thank you. For Starlink, whatever your name is, I'll say it weirdly every time. Toby, why not do your own 100% percent. I think you asked.
You've
this
done
one.
that one.
Yeah, I must have scrolled up just a little tiny bit. You see, I got lazy fingers
Bruh,
sometimes.
you got one job.
Flat out,
What the hell's going on over here?
One job.
And Marinoff tried to do it. He tried to publish his own paper, and he got thrown out of a library window. So,
Allan, why are you trying to flame me, buddy? I give
Trying
you
to keep you on task, brother.
No, you can't do that. I was gonna say it's an ADHD man. You're gonna just throw me right off if you do that. No, all right. Flat out fudge says PhD Tony says so the Earth wouldn't move under the helicopter even with it being suspended in the air. And we did read that one. My finger. I swear. Tony, why do you lie about having a PhD? Awesome town Matt just makes an accusation. Thanks for that. Let's not entertain. Mike Jones says,
No, I'll take that. Any flat earther who wants to know if I have a
taking
PhD,
the
not,
bait.
I bet you 10 grand I do.
Everybody trying to make money on this
Pony
channel.
up the money, put it in escrow, and we can sort this out.
I can confirm that he has a PhD. I just downloaded his thesis like 10 minutes ago.
Yeah, I was gonna say everybody's been making bets on this channel lately. I mean, some people are gonna be losing money or making money. I don't know. Mike Jones, neutrinos are claimed to have 3 natural sources: cosmic rays, the sun, and supernova. Tony is a fraud, and Darryl has. He's just being rude. Anyways, let's just try to ask his question. Sorry, Mike. So neutrinos are claimed to have 3 natural sources: cosmic rays, the sun, and supernova.
Yes, saying that some cosmic rays are neutrinos is not the same as saying that cosmic rays are neutrinos or neutrinos are cosmic rays. It's a logical fallacy to say that a property of the subset therefore applies to the whole. He was looking at studies of cosmic rays and then trying to say, well, this must be what neutrinos are like. And in particular, he was trying to say that this is what solar neutrinos must be like. Solar neutrinos and cosmic rays, the vast majority of cosmic rays, for instance, the ones that produce spallation,
5 seconds.
that produce cosmogenic radionuclides, they are not neutrinos. They interact with matter demonstrably.
Okay. Any thoughts, Darryl, before we move on?
I'm just getting into that. So I'm just aware that there's experiments that detect them, but Tony got it.
All right. Let's reset that timer. And a Philatus says, can an airplane flying north-south land on the equator if the Earth is spinning 1,000 miles per hour east-west underneath it? I'll let you start, Darryl.
Certainly. This goes back to the point earlier, like if you're on the bus and the bus is moving and you jump, the bus doesn't just suddenly speed away from you. So by the same token, relative to the airplane, the Earth is stationary until it takes off. So it only picks up the speed that it takes off relative to the planet. So I'm not sure why that's still such a big issue.
Okay.
Again, the atmosphere is rotating at the same speed, as roughly the same speed as the planet underneath it. So the motion of the plane coincides with the motion of the ground as it goes in, and the pilot will any small residual due to winds, the pilot will correct for.
All right, that is time. So Witzik Gets It says, Tony, can you define a credentials fallacy? 30 seconds.
A credentials fallacy would be somebody saying that they are right just because they have credentials, which is not what I'm doing. What I'm doing is I am saying that I have the scientific literature backing my position. That's not a credentials fallacy. So if I have scientific observations and scientific studies that validate my position, that is not the same as an assertion from authority. And but the fallacy that these guys have is that they are asserting that they are properly qualified to read, interpret, and represent the contents of scientific papers when they are manifestly not able to.
We got to move on.
Yeah, can I make a clarification real quick, please?
Yeah,
I actually never claim that. I'm just a guy that reads PDFs on the internet. So that's explicitly what I don't claim. I encourage people
okay,
to
so
read.
so you're willing to admit
I just need 2 seconds, bro, and I'm done. So anyway, I encourage people to do their own research and not just believe that I read.
But if you're, so you accept that you are not qualified to correctly interpret and represent the contents of scientific papers. Yet here you are doing it.
What do you mean by I don't want to engage with you? Yeah, you're right. 100%.
His argument is that you should hand over the authority of all your thoughts to the institutions.
No, my argument is that you should restrict your authoritative utterances to subjects that you demonstrably well understand. And if science is not one of those subjects, don't opine on it. I'm sure you have a profession that you are good at. I'm sure you are an expert in your profession.
All right.
I don't turn
We
up
are-
at your work
Next question.
and say,
We're good,
you
bro.
don't know what you're doing.
We're moving down
We're
a
good,
different
Brody.
path, Tony. Yeah, we want to have chit chat afterwards. We can. Mind Mastery TV. The globe Earth proponents are actually pushing me away from the globe. Why would you guys need to scream, interrupt, and gaslight the flat earthers? So Mind Mastery is making a commentary on the metas. We've tried to avoid that. I'm so sorry, My Mastery. We've got to move on, and I'm sorry. We've done a lot of meta discussion back and forth. So I am says, thanks a lot, Ryan. You skipped over both of my super chats. We'll try to keep them on subject. I'm doing what I can, guys, but we've got so many super chats, and if they're not relevant, if they're just like, calling out speakers, we've got to move on. We can't just sit here insulting speakers and just making little gotchas. Let's keep it relevant. Richie Constitution says, thank you, Darryl. You proved that Toby and Allan know nothing about science. Globe with the win. So much for relevant. But you know what? I did say we like the fan super chats as well, because we can just move through. Matt Urquhart says, by what mechanism does a coordinate system enable a spherical geometry to work on a flat plane without transforming the object itself? Thoughts, Allan or Toby?
I mean, I don't know. Like I tried to explain, right? It's not like the question's kind of malformed. They're acting like they took a flat Earth map and morphed it to a globe or something. Like I explained earlier, right, that it's all based on centuries of observations being fit to a globe model. I don't have centuries of observations to fit to a flat Earth model to try and extrapolate out distances across oceans. There's really no good way to do that. The only way that they can do it is using the sky and the magnetic field, which it turns out is, not necessarily so straightforward to do. And they have to make insane magnetic declinations, corrections in the south, like insane rates. Like it gets to a point in certain parts of the southern oceans where they have to go like 70, 80% corrections. So, it's not so straightforward.
All right, we got to carry on there. What's It Gets It says, Darryl keeps talking about understanding math, and he doesn't understand the basic equation of MMX. What does the equation 2dx v squared / v squared mean?
It was not necessary to understand that they didn't know what they was talking about. It was simply necessary to understand the Taylor
Damn,
expansion.
dog. Oh,
So
It's his question, sorry.
that's in other words, like, as Tony is talking about, these papers are being done at the PhD level by PhDs. Taylor expansion is undergraduate math, maybe even high school math. So if you don't understand that, you can't possibly understand what these people are talking about, which we demonstrated, and which Tony demonstrated with the Cosmos Grays paper. It's not a gaslighting.
That's time.
It's simply a fact that there's not the understanding here.
We're
Sorry,
moving
Ryan.
to 15. You're fine. I was going to say, we're going to move into 15 seconds here just to get everybody moved out because we're reaching far past the 3-hour mark. LJ, Darryl, why is your background fake, CGI, and not real? 15 seconds.
Say that one more time, please.
He's asking you why your background is fake CGI and not real.
Oh, well, I didn't really pay attention to whether that was really or not. I just thought it looked cool and it represented that I was on the globe side. So, but if you actually have proof that photos that are presented as globe pictures that are CGI, please bring them in and we can talk about it.
All right. Nominal used their super chat, their membership chat to say all the space cameras and Darryl use CGI globe pic.
Bring the evidence.
Shazam says, Toby, Why do you think Tony is such an well, Shazam? That's your first super chat. He asked, "Why do you think Tony is such an angry elf?" That's just not being polite. We've got better things we can say to all of our.
Hey Ryan,
students.
how many more super chats we got out there, brother? Like probably 10.
Yeah, we're getting down to the bottom of the list here, so
All right, cool.
don't you worry, buddy. I'll get you out of here in just 2 seconds.
Cool.
Don't worry.
Yeah, you're good. You're good.
Yeah.
I just wanted to get an ETA because it's like, so as long as I know how much time we got, I can make it through the rest of this.
Oh yeah. What time is it for you, bud?
Let's keep going.
Okay, no worries. Cool. Flat earthers, how high is the sun, and why, when you use common flat earth claim of 3,000 miles into a right angle, you find the sun would never go below 13 degrees in the sky at the furthest point, making sunsets impossible? You only got 15 seconds, so make the best of it.
Wow, that's a really good question. I'm going to have to reconsider my flat earth position. I hadn't looked into sunsets.
All right, any thoughts over there, Toby?
Yeah, the sun appears to be in a apparent position. If it's being invoked through a dome, then that's going to make it even more complicated. And there's insane levels of refraction. If we don't even know the distance, we don't have observations of things at 3,000 miles in any other context on the Earth. So you have no idea what's going to happen with refraction rates at those sorts of. Yeah, there you go.
Thank you so much, Toby. Eric Burns says, Toby and Allan, if a boat on the horizon goes out of view, why can't we see stars on the horizon, which are further away? Perspective isn't an answer. I'll give you 15 seconds each. Toby first.
I made it pretty clear earlier, but it's all about angular resolution. So if the distance of the star is further, then it's going to have even less angular resolution.
Any thoughts there, Allan?
Yeah, so you missed the question.
Tony, it's their
Why
question.
can we see the star with smaller angular resolution than the boat?
If they missed the question, I'm so sorry. But yeah, Allan, did you have any any thoughts on that for 15 seconds?
No, we're good. Continue.
All right. Rodney Borden asks, why do globers always invoke a closed system with a solid barrier? Then they try to explain why the Earth never rotates underneath airborne objects. Thoughts there, Darryl?
Evoke a closed system. I don't remember ever saying there was a closed system. Stop lying on our position. That's one of the things
What
flat
holds the
earthers pretty
atmosphere
much
in?
have to do.
All right, sir. Question. Any thoughts?
Yes,
Tony?
that would be gravitational acceleration that cleaves the atmosphere to Earth, just like it does for Venus, just like it does for the Sun, just like it does for Saturn. The idea that there needs to be some sort of container is gibberish.
All right, thank you. Dan Hoffman. Tony, he's asking why you scream and lol. Darryl, he's accusing you of why are you guys gaslighting through the entire debate is what Dan is accusing you guys of.
I mean, I pulled up the article and showed. I asked them what this fourth order means. They didn't know. I asked what a Taylor expansion means. They didn't know. They pulled up the cosmic ray article, didn't relate to neutrinos. They didn't know. I didn't gaslight. I simply pointed out a fact.
Okay, any thoughts there, Tony, before we move on?
Yes, I do. Pointing out that they don't have a sound scientific understanding is not gaslighting. What we should have spent this entire debate doing is talking about observational evidence. We should have been talking about train tracks. We should have been talking about shipping lines. We should have been talking about navigation. But instead, they want to imagine that they understand scientific papers.
You can't let him sit here and just insult us like this. This is insane, Ryan.
That's why I'm trying to insane. I'm trying to bring it forward.
They both just like literally sat there and insulted us. Now we don't get a chance to respond. That's crazy.
I don't even want a chance, dude. I just want to get through this, dude. If you can do your answers without gaslighting us or insulting us, that'd be much appreciated, bro. We got shit to do after this. Let's wrap it up.
Saying that you don't understand scientific papers is not an insult.
All right, let's roll it. Let's roll it out, guys. We only got just a few more to go here. A few more to go. What are you guys doing? Let's see if we can really go through them because there's a few. Kango 44. I have a question for the flats. If I'm standing in Auckland and my mate is standing in a bluff that's 1,600 kilometers apart, experience sunrise at the same time, why does my other mate in Sydney, that's only an extra 680 kilometers away, have to wait 3 hours for sunrise? Any thoughts there, fellas?
This is a non-exclusive question. This would be the same on both models. I mean, our model is really easy to explain. We literally just look at the sky and say that's the model, right? Like
Yeah.
it's just it's a if you're going to invoke, like we already went over earlier, there's literally a kinematic equivalence in your model because you have to invoke this like crazy pseudo force. You have to call everything pseudo forces. You have to essentially you have to assert the idea that all reference frames are equal.
I moved it down to 10 seconds. We are in speed round mode, guys. What's it gets it? Darryl keeps talking understanding math, and he does not even understand the basic equation of MMX. What's the equation of? He's asking the same question. You got 10 seconds.
I think you reread the same one, bro.
I think Witsit might
Yeah.
be asking it again because he's.
It's okay. I yield his question,
Negative
and he doesn't
goal.
have to answer that. You're good, Darryl.
It's the formula for the fringe. It's the formula for the fringe offset.
Respect, Tony.
All right. Let's see. Kango 44 question for Witsit. Witsit's not even here, Kango. Is the money for you to spend on super chats coming from your audit NASA fund? Oh, you're so silly. FE Nation says, for the globes, we can experiment. Come to Tennessee. We will go 8 miles away from the phone towers. GPS and phones don't work. Explain why. 10 seconds.
Well, that's interesting because I've been into the highlands of New Guinea where there's no radio contact and no cell towers, and I was able to make GPS observations perfectly.
That's
so
tough.
I don't know what you're prattling about.
Witsit gets it. Audit NASA fraud didn't even raise enough to pay for the website. I paid for almost all of it out of my own pocket, but by all means, keep slandering me. He responded to Kinko. Joshua Jamie says there are stars seen in Egypt and Cyprus, which are not seen in northerly regions. Aristotle, 10 seconds, panel.
Yeah, that's because we're on a spherical body, and as you move south, you can see stars that are further south.
That's time.
It's fairly easy.
Count Discalcula says, talking about credentials and professions to all, what is your highest level of education? What is your specialist topic? What is your profession? Sorry, Count Discalcula, but that's very personal. If you want to learn more about our speakers, they will be tagged in our description at the bottom. If we don't have their links there now, we will post credits here. So just stay tuned for that. And anybody who doesn't have their link there, send it to me and I'll try to get it in there before the end of the night. Mr. E-Man says, for Allan, can you explain the Chelyabinsk and Taganska events?
Chelyabinsk and Tunguska.
Thank you.
Never
These
heard of it.
have extensive scientific studies. There are people who have purchased parts of their meteorites regarding these events. So we can move on if that's...
Yeah, I'm not sure.
All right, Witsit gets it
Never heard
says...
of it.
They're meteorite impacts in Russia,
All right,
one of which
Oh.
was filmed.
All right, sorry,
Oh,
Tony.
bet.
I will connect you guys via
nah.
email, but yeah, we'll try to hurry up just because, like I said, Allan's got some other stuff. He's got 10 too, and we're a little over time. Witsit gets it. Since you claim we have two default to credentials in the field, is PhD Robert Bennett thesis and relativity correct when he says Earth is stationary? 10 seconds.
No. He has to, in order to be accepted as valid science, it has to be published, peer reviewed, and then validated by subsequent studies.
Witsit gets it asks, from divergence to convergence, centrifugal and centripetal forces in history, Cambridge University. Tony, is Cambridge University using word salad? 10 seconds.
Can you repeat the question?
Oh, yeah, I'll pause that. From divergence to convergence, centrifugal force and centripetal forces in history. Cambridge University.
Without context, his question is meaningless.
Okay. Witsit also asks, so Tony, you cannot explain GPS meridian corrections, but you claimed Allan was wrong about it.
I looked that up. There's no such thing, Witsit.
He says, LOL.
You pulled up the paper I told you to grab?
He
Sorry,
says,
go ahead.
Since I was speaking at the time and you haven't shared it in chat,
I didn't finish the question.
Told you the title.
perhaps don't interrupt me while I'm talking, mate.
Told you the title.
All right, the question wasn't
While
over.
I was talking,
GPS
dickhead.
So hold on, the question's not over. So he said, this is weird. Maybe Allan can help you understand.
I doubt it very much.
Yeah, so it's in the paper that Toby referenced, what Paul
Just
Marmay
linked it.
referenced. Yeah, what Paul Marmé references in that paper are the international clock standards for synchronization for two different organizations. So if you're familiar with like the IEEE, the two that he references, like the equivalents of that, it's the IRU or something like that, IRUC or something like that.
That's done.
So anyway, it's in there.
Thank you
So,
so much.
so you're sending me a reference from Biological and Health Sciences. That's the journal you're citing, in relation to GPS. Biological and Health Sciences, that's the journal.
Okay.
And
So
you
are you-
think
I
it's
suppose that-
relevant.
So
That
you're
is
gonna attack
not
where it's
valid
published, or are
science,
you
mate.
gonna-
That's just somebody's opinion.
All right. We got to
So
move
you're
on.
afraid to
He
look at it
cites
and have a
international
contention to the
clock
methodology.
standards.
Give
Like,
it
bro.
away. That's
Literally
nonsense.
references
It's got
engineering
absolutely
documents, like I
no
told you
scientific
earlier.
validity or scientific
Triple E
weight
docs.
whatsoever.
Let's move on, guys.
So-
Zone Television Media asks, why do flat earthers use conjecture and deconstructionism? What are with all these terms this evening? Toby, 10 seconds.
Sorry, I missed the question.
Why do flat earthers use conjecture and deconstructionism?
Deconstructionism.
They missed it. Yeah, I was going to say that's why. It's not.
The question's malformed. I'm not going to answer it.
It's typoed. That's why I can't pronounce
Well,
it.
it's not. I'm not blaming you. I'm not blaming your misreading of it. Like literally, the question's malformed. It's a gotcha question. They're baking their assertion into the question. So if I even answer the question, it's kind of like like they're winning.
No worries. Let's carry on. Kengo says, "What's it spending?"
Someone trying to jerk you off online, Toby? Is that what's happening there? Jesus.
My, what just happened? All right, Kango 44 says, wow, Witsit spending all this grift money tonight. Kango's coming right at you, Witsit. Maybe you should hang out together and get your grievances out. Matt Urquhart says, Flat Earth, is it logically valid to accept a person's expertise as a good reason to believe their expert advice is true? Allan, 10 seconds.
Yeah, so I didn't listen to any of that, and I don't want you to reread it. I just want to move on to the next question, please. Thank you.
Did you have any thoughts there, Toby?
I missed the first half of it. I heard special relativity
Don't
isn't
make
true.
him reread it, bro. Let's roll.
We got to try to give what Matt paid $5 for this, man. Flat Earth, is it logically valid to accept a person's expertise as a good reason to believe their expert advice is true? 10 seconds.
Oh,
Not
sorry.
really. I mean, it depends on the context. I would want to, it totally depends on the context. Am I talking about the ground beneath my feet and about, am I taking my information from, people like
That's tough.
It really depends on context. You have to dig into things yourself. It's about nuance.
All right. Taking Back Eden says, Darryl, do you think you evolved from apes on the Earth? 10 seconds.
Well, I didn't really look into evolution too much. My understanding is that's the current understanding is that there was evolution over millions of years or whatever. Can you speak to that, Tony?
That's tough.
Yes, I can. Not only did we evolve from apes, we are
5 seconds.
apes.
All right, thank you so much. The Science of Science, globe believers, what is your best evidence the Earth is a globe? Convince me. I have never seen any compelling evidence. 10 seconds.
Okay, well, the recursion of seismic surface waves, they propagate out from the source, go around to the other side, come back through multiple circuits, and they do this multiple times. So the same wave goes down, and then the other wave comes up, and so you can tell from the direction what's happened.
All right, thank you.
That's only possible on a sphere.
All right. Alexander L. says, Darryl is low-key killing it. There you go. You got a fan super chat coming in for you as well. All right.
I have to second that.
I think everybody's gotten at least one. That's kind of nice. Witsit
Excellent.
says, Tony, your model objectively requires velocity assumptions. How do you verify the layer compositions? You cannot, and they have actually been proven wrong.
Proven wrong is a complete misstatement. That's Witsit lying again about the contents of scientific journals. And we know the material composition on large scale. We can calculate. We can construct minerals. We can subject them to high pressure and high temperature, and therefore we can work it out. And we work out that that's a pretty good estimate for the baseline, and that the anomalies from that are small.
He's coming back with another one. Witsit Gets It asks, volcanic rocks don't tell you what is 200 miles below. LOL. 10 seconds.
That's not true. That's absolutely not true. Mid-ocean ridge basalts come from hundreds of kilometers deep. That's just another barefaced lie.
All right, Mott asks, Witsit gets it. Your model of flat Earth requires funny physics. How do you back any of it? Well, Mott, you better come back here when we have Witsit on and ask that question because he's not on tonight. So we're going to carry on. Witsit gets it. Asks it. Actually, credentials fallacies is dismissing someone's argument because they do not have the proper credentials. So would you like to admit you were wrong?
No, I wouldn't. So I'm not rejecting their arguments because they lack credentials. I am objecting to what they say because they demonstrably don't understand what they've read. Okay. That's why I'm objecting, and they can't produce any objective evidence supporting their interpretation of these articles. Okay. They're just saying that they understand them and that this is what the articles say.
Let's move on, Tony, because we're just almost to the end here. So 2 more questions, and we'll be able to get to our closing thoughts and let everybody know where we can find you. Matt Hightower says, what is making the Starlink satellites visible in the night sky, and why do they dim and disappear at a higher point sooner than the sun does at the horizon? 10 seconds.
He's asking about the sun converging into the horizon. Again.
No.
What was he asking then? Can you enlighten me?
He's asking about Starlink satellites, what illuminates them, and why do they go into eclipse?
10 seconds.
I don't know. I don't know what illuminates this. Are you asking us or you guys?
He's asking you guys.
What illuminates the Starlink satellites?
Yes.
I don't know.
Any thoughts, Allan, over there, or do you want to carry on?
Okay. Carry on, sir.
Rodney, one more to go. Rodney Borden says closed system, LE inside a train, car, bus, etc. So they're making a declaration it's closed system. So
no, we're not.
All right, let us do our closing statements here, guys. I'm so sorry if we sped through some of the questions a little quicker than we usually do. There were so many. You know, if you don't feel like we expounded on it enough, hopefully we'll see you next time and we can get some questions in the regular chat. Let's do 1-minute closings here, guys. I usually start on the other side. Tony, first minute on the floor, your closing thoughts.
Okay, I want to say I do get heated, I do get shouty, and I do get interrupty, and I apologize. I think that Allan and Toby have been remarkably civil interlocutors and have tolerated me quite well. I do not intend the statement that you don't understand the scientific papers to be an insult. It's just a statement of fact. I don't think you guys are stupid. I don't think you guys are just making shit up. You're doing the best you can with very difficult topics. But you're going to need a lot more. I think if you dedicated yourself to getting an education, I think you could properly understand and represent the contents of these papers. But you don't have the technical skills necessary. That's just a statement of fact. And I don't mean it as an insult because I think you're both quite bright, quite articulate, and very, very well-intentioned individuals.
10 seconds. Oh, all right. Wrapped up there. Well, thank you so much, Tony. We'll actually bounce it this time, and we'll hand it over to Toby. 1 minute.
Yeah, so I don't know, just real quick, like I said earlier, the problem with the mindset of this whole thing of needing to have credentials is that you're literally handing all of your authority of your thoughts over to the institutions. And Tony says, I need to get an education. Like that's literally him saying you need to be re-educated, right? That's what re-education is. But I dive into these things earnestly from my own point of view. We go through every Thursday night at Ether Cosmology YouTube. We read papers live on. We're not like I said, this whole thing. Like if I didn't understand something, I wouldn't be afraid to say that. I'm not like when he brought the paper up earlier with the proof of relativity. I told him I'm gonna look into it. Like I'm not gonna know what's in the paper before I even read it. But the ground beneath your feet's not moving. The speed of light is definitely not constant. The twin paradox is nonsense. The whole thing of a cat being dead and alive, having poison in a box in a superposition, it's all nonsense, man. The classical mechanics makes everything so much more simple. The ground beneath your feet is flat and stationary.
Thank you so much, Toby. And thank you, Tony and Toby, for being here. And I'm going to hand it over to Darryl. 1 minute on the floor.
Yes, thank you for having me. It was a pleasure to be here and be on the same side as PhD Tony. I'm a fan and I want to be a PhD, so I really appreciate it. And I enjoyed it and I thought it was fun. I think you guys are cool guys as well, so it was nice talking to you. So the audience, I'll just say, if you ever see one of these flat earthers, or some of them are too dishonest to even admit that anymore, and they say they're globe deniers or whether they concave or whatever. And then if any of them are saying that science or math or a scientific paper or anything like that supports their position, look a little deeper and you'll find that either they're lying to themselves or they're lying to you. It's pretty simple. And it always, when I see people saying, oh, they're killing them, and all they're doing is just glossing over math that they clearly don't understand, it's so easy to debunk if you just go below the
10
surface
seconds.
level word search type of arguments that they make and actually learn science and math and actually look into it. So thank y'all.
All right. Well, thank you so much, Darryl. And Allan, last word to you. 1 minute on the floor.
Yeah, shout out to the opponents, man. That was a really good let's get out of here, man. Let's wrap this shit up.
All right, buddy. That's why I was handing it over to you. Let's wrap this up as he drops right out. What a Class A act. All right. Well, thank you, everybody, for coming out to Modern Day Debate. Thank you to Toby, to Anthony, and also to Darryl. And oh, my goodness, now that he dropped out, I just forgot your name, Allan. I could never forget that name, honestly. That's just a joke. So thanks again. And I'm going to close it out once again with some original music that I just recorded today, because why not? You all asked who was screaming. You want to hear who's screaming? It is me now. So I'm going to let our speakers go, and you all just sook and suffer to my first demo. Cheers, everybody. No matter what you think of me, it's only half of what I am. I'm the greatest, I'll set you free to sin, and I won't give a damn. I expect complete conformity, or I'll cast you aside. I spit upon your decency and swallow up your pride. Everything to you, hear my call out to war. The fake news says now I'm a